right. All right, we are recording. All right, so this is the first session of three sessions when it comes to programming and building a robot. We will have the next session of this playlist is going to be beginning programming. So I'm going to teach you guys all the basics, what software to get, where to get it, how to get the documentation. Documentation is king. So where to go for all of that, and then we'll get into more advanced programming, like programming Swerve, programming autonomous, and all of those things. So, who am I? I'm Roger Johnson. I'm actually what I do for a living. I'm the CIO of a big distribution company in South Bend, Indiana. So I manage all the technology and all the technology people in a corporation that spans across all our surrounding states. I'm also the FRC assistant coach of 5484 under the head coach, David Eversole. So we've been competing. We've completed 9 years of competition, even though it kind of feels like it's been 7 years because we had 2 years of basically no competition. So this was our 9th year, and we're going into our 10th season in robotics. So we've been doing this quite a bit, and just like all of you, we've had to learn from scratch. Our head coach was actually an alumni of Penn's team. He was actually walking in the door now. So he was an alumni of Penn's team. So he was a student on FIRST. And when he started here at our school, he actually started a team when no one here knew what it even was. Actually, would you like to give your story on how you started our team?
Sure, I came in drunk.
Well, why don't you come over here? Hang on. Come over here and talk to the mic. Yes, you're being recorded.
Yeah, I wouldn't say that.
Watch the cables right here.
Both these cables?
Yep.
Okay, so I was actually going to school for a math degree, and then I was working as a bartender at Fiddler's Hearth. A couple of my regulars asked me what I plan on doing with my degree. I told them that I was planning on teaching for 5 years, maybe go back to my doctorate. I'm like, well, you need to come check out this school. So I came and did a tour. I had an interview with the superintendent on the tour, and then I did really well in the interview. And as I was walking out, I turned around and pitched FRC to the superintendent, and he goes, I have no idea what the hell you're talking about, but you seem to go for it. And ever since then, it's been a non-fleeting look back. So that's where we are today. And after 9 years of grueling sweat and tears and growth and learning from our failures, we have developed a pretty successful team, I think.
Yeah.
So,
Yeah.
that's my story, and I'm sticking to it.
Now, one of the things that he always leaves out when he's telling the story, but it's important for especially new teams. When he started the team, he sent out an invitation to all the students in the school and to try to drive up some excitement. And on kickoff day, he went and bought pizzas and a whole bunch of things, had donuts. He was prepared to have a whole bunch of students ready to join the team. No one showed up. Not a single student actually showed up for kickoff. And he called them, and he's like, where are you? And they're like, oh, is that today? And
There was one kid who said, yeah, I didn't feel like coming.
yeah, I didn't feel like coming. So don't get discouraged. Honestly, most students do not understand. And in fact, the students that we have joined now join because of the excitement of current students. They're like, okay, there must be something more to this. So they join, and then they go through build season, and all of the students are like, why are you doing this? This sucks. This is so much work. And then they go to competition, they're like, okay, all right, I get it. I get what it is now. And so our first years are always kind of like, eh. And then after their first competition, the next years, they're all in. They put in the time, the effort, everything. So don't get discouraged when you're starting off because it is hard. It is hard for mentors too. Because mentors are like, oh my Lord, this is way more work than I expected. And it's really hard, especially as a mentor, not to just do it for them. You have to just teach them, right? So guiding them through the process when it's like, all right, let me just fix it for you. Guiding them through the process is one of the hardest things mentors have to do. So don't get discouraged. This stuff is not easy. If it was easy, it wouldn't be fun. That's the truth. If you want it easy, go do Vex. So FRC is a full-out sport, and there's nothing like it for high school students. Nothing like it at all. All right, so what is this course about? Well, this course is going to be based on the 2023 FRC season. So if someone's watching this 10 years from now, it's not any useful to you anymore because I'm sure the game's going to be quite a bit different at that point. This is an introduction. You're not going to walk away being a complete expert, but you will be able to identify what everything is and know where to go. So you won't be lost. The whole point of this is not to be lost in what all of these things are and what they're used for. It focuses on common FRC components. Now, FRC doesn't have much of a limitation on what you can put on your robot, right? So you can put you could put a big, massive Google LiDAR that you see on Google Maps on top of your robot and program it to that if you want to. But is it really that useful? It's another question, right? But we're going to be focusing on the common parts that you will find in the kit of parts, the main brains that you're required to use and stuff like that for our program. You will need to learn more. So again, this is an introduction. There is more to learn, okay? And the easiest way is to ask questions. And with that, you're not the first. You will not be the last person learning all of this. So ask questions and answer questions. So do not be afraid to ask. The whole reason mentors are here is to answer your questions. And if a mentor doesn't know, a mentor has a mentor they can ask. That's literally how it works. So if you don't know, ask questions. And if your mentor doesn't know, your mentor should hopefully be able to ask. Heck, any of your mentors, anytime, can ask Dave or I, and we will either answer the question or we will find out that answer themselves. So let us know and we'll help you out. But that also goes for, especially you students, your jobs as experience, so you've had 1 year under your belts, right? So your job is to help the new students coming on with what you've learned from so far. Make sense? All right, so first, especially for the newer students, what is FRC in the game? We need to understand that whole aspect. So the FRC game, which is First Robotics Competition, is basically 6 robots that are about 150 pounds competing on the field, competing as an alliance to complete the objective of the game. The trick with FRC is the game every year is new. It's never been played before. Every year is a different set of tasks that you have to accomplish, right? And you don't know what that game is until the first week of January. So you have this whole first semester of school that you're prepping to be able to build a robot, but you have no idea what kind of robot you're going to need that year, right? So you're just learning what you're doing here. You're learning the components, you're learning the basics. But the first week of January, you now have 6 weeks of learning what the game is to design and fabricate and program a robot that will compete and accomplish those tasks. That's where all the stress comes in. If they told us that right at the beginning of the school year what the game was, it wouldn't be nearly as stressful because you have plenty of time to do all that. But what their desire is to create a real life work scenario. In real life, you're not usually given just gobs amount of time to accomplish a task. You usually have to do it under pressure. So that's what they do here, because what they're trying to do is prepare future engineers for the real world. And Demon Kane actually has a famous saying. Now, I've talked to you that FRC is a sport. It's a sport because you're competing to do physical aspects, right? So it is a sport, but it takes brains to do it. Dean Kamen says it is the only sport in America where everyone can go pro. Everyone that competes in FRC can go pro. And I really like that because it's what your guys are learning how to be is problem solvers. And you can all go pro in that. So, how it works is you have two sections of a competition. You have the qualifications and you have the playoffs. During the qualification rounds, there are anywhere from 30 to 52 teams that will be randomly paired up together in groups of 3. And you play as an alliance. Each round, you're randomly grouped up with other robots. So there's 3 robots on each side, a red side and a blue side. And you compete together as an alliance to try to defeat the other alliance by outscoring them. This is the red and the blue side. So if you have ever watched videos, you'll hear red alliance and then blue alliance on the other side back and forth. They're randomly cheering on that group that's been selected during qualifications. The game is a 2.5-minute game. So the first 15 seconds of that 2.5-minute game is all autonomous, meaning everything those robots are doing on the field in the first 15 seconds, they're doing without any human intervention at all. It's all automatic. Then we play 2 minutes and 15 seconds of teleop. So teleop is where the human is driving the robot, driving the functions of that robot. And then the end of the game, we call end game, but it's still part of the teleop portion. End game is some final task for the robot to complete before that round is over. After you've completed all of your qualification rounds in the game, what you're actually going to have then is what's called an alliance selection. So the top 8 robots that were ranked based on their actual qualification rounds, the top 8 robots will go through and select other robots to play with them in finals. So unlike qualifications, where you're randomly paired up with people, during playoffs, you have more control of picking who it is you want to play with. And there's a whole bunch of rules that goes into how they do that selection, and we're not going to be talking about that. The important part is we get to pick our partners in playoffs. And then we have playoffs, very similar to brackets like you would see in basketball, similar to that. But we would actually play off until we get to the final, and then the 2 top surviving alliances will compete for the champion. So that is how the game is played. You guys have any questions about that? You've gone through one season, so you've seen it a bit, right? You've seen the stress. So I describe it as it's very similar to NASCAR, where you have to quickly get onto the field, get ready to play, get the robot on, make sure everything's perfect, get really nervous until that match actually starts. Then you got to rush off the field back to the pit so you can start making all the repairs that you need to make to your robots or the changes that you make, because you have a very short amount of time before you have to get right back onto that field again. So it is an adrenaline rush for the pit crew and the drive team and everyone watching them in the stands. Oh my God, are they going to get it fixed in time? We'll find out. There's been several times where, like for us last year, got to end game and our robot went up on the charge platform and we saw the arm slump off to the side. We're like, oh God, the bolts came out of the arm. And we then realized that in our design process, we did not actually make a very friendly way of accessing those bolts. So some pit modifications to the robot to quickly get all those bolts back in, because again, we couldn't just take it all apart and just make sure everything is good. No, we had like 10 minutes to fix the problem and get it back on the field. You will actually see teams that have big breaks that can't fix it in that short time frame, and you'll see like ratchet straps holding parts in, or lots of zip ties. Zip ties are everyone's friends when it comes to robotics because we zip tie everything together. We even have these really large half-inch zip ties that can like hold a bull down to the ground that we've had to use every so often to make sure our mechanism doesn't fall apart as we're there. So it's absolutely adrenaline rushing, and I actually serve as the drive coach on a team, so I'm usually on the field, and yeah, I have panic attacks all the time personally when things are going awry. In fact, I will tell you as a drive coach, it's more fun when we're losing than when we're winning because we always can improve from losing. When we're winning, it's always, oh crap, how do we keep up? How do we stay up that way, right? How do we keep winning is so much harder than, all right, let's try our best this time. But it is addicting. Watching in the stands is almost more nerve-wracking to me because you can't actually get out there and help them when there's something going on. I can actually personally say that I know our head coach, Dave, yells a lot when we're competing, but I am so in the moment, I can't hear anything he's saying. So he says coaching from the stands. And the thing is, I could make the argument, it's like, I don't even hear him. So none of us down on that field, actually, we cannot honestly hear the crowd at all. When you're driving that robot, you're blunt to the rest of the world. You really are. There's nothing else happening. There's no one else in that arena. It's because you get just so focused on what you're doing at hand. It's absolutely thrilling, but it's also a lot of pressure. We will actually have some drivers that turn out that they don't want to do it because of the pressure, because it is a pressure, right? But it's so much fun. So the first thing that what we want to talk about is documentation. There are two sources of documentation for everything that you could possibly want. You have the WPI documentation. WPI is a college, and they actually program the robot base code for everything in robotics. They've programmed the FMS system, which is the control system that actually controls all the robots during competition, and they've built all of the tools that you use to actually work with your robot. So WMI is incredibly important, so I'm going to actually click on this. Both. Yes, you can actually go to WPMI as a college. That's a good question. There we go. Perfect. So this is their document source for everything that is robotics. And you could absolutely know nothing at all about robotics, and this will actually step you through everything that you need to know. It has an introduction, and I love their actual beginning, Zero to Robot. It actually steps you through everything of what it is. Next step is how to wire your robot. And it has one of the best diagrams that have ever been created for wiring up your robot. So it not only tells you and shows you everything and where it plugs in, but what gauge of wire you have to use.
You can actually buy that from Andymark. I highly recommend having it on hand. It is incredibly useful.
This printed out?
From Andy, they sell it.
Oh.
They just recently started doing that 2 years ago.
That's awesome.
But printing it out on a plotter, having a poster board with it,
Yeah.
very useful.
Very, very useful, and it's very handy for anyone that's new. This is like the godsend when it comes to how to wire everything up. And they keep it updated as the technologies update. They keep updating the system to show the new items. So it goes through and then even has example pictures of all of this wired up. Personally, I do not recommend. I recommend bolting things down, not zip tying them down. But it goes through detail. It even shows videos on how the connectors actually work. So you can really understand and wire everything up. And we're actually going to be talking about how all of this works. Then it even goes through and steps you through the software that you need to actually program and manipulate your robot to control it. Preparing your robot with the radios, the Robo Rio 1 or Robo Rio 2 and your radio, and then beginning programming your robot. So it has all of the documentation. Now, as a first year, you're going to go through this like the first time. Then you know where everything goes. So you won't have to worry about it nearly as much in the future. I don't need to go and look at how to wire my robot. I know how to wire my robot now, right? But it has so many other different things. It can show you, hey, I want to use the pneumatics hub because I want to add pneumatics, and it will actually step you through all the different things to actually use that device. Really, really great. Now, the one thing that WPI does not have is it does not have game rules and regulations. It talks about components and code, right? To get rules and regulations, where we need to go is the First Inspires website. So we're going to go to the First Inspires website. And if you go to programs, first robotics competition, you'll have game and season. From here, you'll get this page, and this page will always be the current game or the upcoming game. As you can see, it's Crescendo is the upcoming game. And you'll see game, manual, and season specifics. When you go to that, you'll go here. Now, right now, even though the site says Crescendo, the game manual is not available. It won't be available until kickoff, right? So what here they're showing is last season's game manual. But it has all of the rules and regulations and details about running an FRC team and the details of the game that year. This is where you'll always go to find out all of those specifics. We, on our team, will actually go through and create a quiz on the rules every year. And one of the things that we require out of our drivers is that they understand all the rules. Because they need to if they're the ones actually playing the game, right? They need to understand all the rules that apply to playing that game. But we want all of our team members to actually understand the rules. Because often we'll get questions like, why don't we just go over there and tip over that robot? Well, because you can't do that. It's against the rules. What is that, a G20? I can't remember. For tipping. G15, G23. Yeah. Yeah, yeah. So the thing to remember, and this is a question that we get from every first year, or people applying, is this BattleBots? This is not BattleBots. Yeah, this is not BattleBots. To a point, yeah. It's more like bumper cars. Not BattleBots, bumper cars. We are not, if we have built a robot that is intentionally or not damaging other robots, you will not be playing the game for long because you will keep getting disqualified. And which means no one will pick you when it comes to playoffs because you're not going to be in the top 8 if you keep breaking other robots. Simple as that. Right? So no one's going to pick you during playoffs either because they don't want to be disqualified during playoffs. So our goals, we're not here to damage other robots. Now, do we want to defend against them? Yes. But our defense is limited to bumper cars, right? Nothing more. We cannot develop an arm that goes in and rips out the wires. We cannot have a little cup of water balanced on our bumper to dump into another robot. Yes. And you cannot ram someone so hard that it's just going to dislodge bolts no matter what. So we're not here to damage other robots. We're here to play with other robots. And the other reason that we don't want to do that is these robots cost 10 grand after all is said and done. Between the electronics, components, and all of that, these are $10,000 robots. We are not going to destroy them. And the more we beat our robots up, the less we are able to survive competition season. Because the harder you're hitting people, the harder you're pushing your motors, the harder you're doing all of that, the more problems you're going to have later down the road during competition. Which a lot of teams have had to replace their entire drive motors because they burnt them out by pushing other robots around the entire time. Your goal really is to get around other robots. So you can find all of the details and the regulations about the game during the game manual, but you can't get the game manual until when? First weekend in January when they actually release the game. Now, I will tell you, first we'll keep releasing teasers to give you some hints about what the next game is. I will tell you, we've always tried to find a pattern. I think everyone in the world has always tried to find a pattern. And it turns out that most of the 99% of the time, the trailers they release have nothing to do with the game. Nothing at all. So they're not hints at all. I don't even bother watching the trailers anymore because it's not even good marketing. So, yeah.
Well, this crescendo, but last.
Charged Up, do they have a? Yeah, I think they did.
It's usually premiered at Blades.
So, yeah, they had 3 or 4 trailers.
So when I was in school, it was an actual hint. It was something with something about a shovel's show. And it was David Spade was just shooting, and it was a whole thing about aim high.
They used to do it back when I was up in Michigan. And it was the teasers were you could really start to kind of figure out what you would have to do. But now I was watching it the first time back.
Yeah, I've been doing it for 9 years, and I just stopped watching the trailers.
For 9 years too.
I have been doing it for 9 years. I should tell that story real quick. How did I get into robotics? I got into robotics. I am not an alumni. So even though I graduated in 1996, they actually had robotics then. My school did not have it. In fact, the school I graduated from still does not have it, and I want to try to actually help them change that. But I got into robotics because I was sitting in the computer lab where Dave Ebersol was holding one of the first team meetings, and he was a little fired up. The students that he finally got into the program, he got them there, and he started giving this speech about what robotics is, and he was getting more and more animated in his speech, where he's like, you should never ever come to school and think, is this the day I get suspended? And I'm like, so he gave this whole speech about what robotics is, what it's about, why we have it, why it exists. This is not just a little game club. This is something that is supposed to energize you into your future. And I don't know if he motivated the kids that day, but he sure motivated me. So I joined the team after that, and I have been suckered into doing it every time after that. So I've been doing this, I've been assisting Dave for 9 years. Fortunately, I came with a background of robotics, robotics, but I have a background of programming. So I was able to step in on that position and help him with that. The first 2 years, I just helped you with actually leadership, teaching Dave how to be the amazing leader he is today. And then I went into the programming role. We lost our programmer, so I went into the programming role, and I've been programming it ever since. Now, that decision I haven't decided if I regret or not yet, but I do have a lot of fun doing it. All right. Now let's talk about power. How do we power all of this? Do you guys know AC/DC? It's an amazing band, isn't it? Yeah. But we're actually we're talking about a different kind of AC/DC. There are two different power types that we can use in electrical systems. We have AC power and DC power. DC power was the very first electricity that we used at all in the world. It's direct current. Direct current means the electrons flowing through the medium are actually flowing through the copper line. They're actually being transported through that copper line. And it's a nice steady flow of electrons. The problem with DC is the longer it has to go, the more resistance it's hitting as it's going along. So really long lines and high power of DC tends to melt cables. Something to keep in mind. Well, then along comes Tesla. Tesla, the actual inventor, not the car, Tesla invented a new way of transmitting electricity called AC, alternating current. So DC, direct current, AC, alternating current. Instead of pushing that electron all the way through that line, he was going to actually take the, I should have a picture of it. What is, you know those devices you see in like psychology offices where you let one ball go and it hits, and the other ball goes and hits and it goes back and forth? What is it called? Newton's cradle, yes. So a Newton's cradle is how AC works, right? Instead of pushing this electron through this tube of wire, I'm going to ram it and pop the electron out the other side. And then I'm going to reverse the flow and go back again, and reverse the flow and go back again. That's how AC works. Now, the nice thing about that is I'm not ramming all these electrons through these lines. So I can actually, at that point, have a large amount of power running just micro distances. So I have far less resistance. Far less resistance. That is why you've seen the big electrical transmission lines that power all of our homes, right? That's all AC power. We all have power today because, and without a generator like running every house, we actually have power from a central station that can be located hundreds of miles away from us because of AC power transmission. Those lines, those carrier lines that carry power to our homes can be somewhere around 100,000 volts running on those power lines. Now, 100,000 volts will kill you, right? That's a lot of voltage, but it doesn't carry much current. So how do we get current out of voltage? Well, we take it down to what's called a transformer. We step down the voltage, which increases the amperage. And amperage is what we actually do work with. So between AC and DC, what do you think our robots use? You would think so, right? Believe it or not, it uses DC though. This is why. All of our computers, all of our electronic devices, our smartphones, everything all uses DC. Because it's using electrical components that need that actual transmission of an electron, right? Remember, AC is not transmitting electrons. It's just hitting them. DC is actually pushing the electrons through. So we actually use, all the electronics use DC current. Now, you guys, so I have over here, this is the power brick for my laptop right here, right? This power brick plugs into the wall that is powered, again, all of our walls, whoops, that's my table, all of our walls here are using AC power, right? Because that's what is generated and sent to us. But again, none of our computers can use AC power. It needs that direct flow of electrons. Those power bricks that are on our computers are converters. They're transformers. It's actually taking that AC power and converting it into DC power for electronics. Do you know your cell phones? Everyone's got one of those. All of your cell phones, they have little power bricks that you can plug into the wall. What do you think those little power bricks are for? Convert the AC to DC, right? So all electronics use DC power. So now, what do you think our robots use? DC power, right? We use DC power because that's what all the electronics need. Now, in real life, electronics can actually have a variety of AC. Like we have some AC motors, we have some DC motors. So there can be a variety of mix between those two. You have to know what it is you're using and not use one or the other. So you cannot use an AC motor in FRC robotics. You have to use DC motors. So, what exactly is our robot using? It uses a standard battery. Typically, it's a type of battery you would find in larger motorcycles. So it is a 12-volt battery, and there's only certain batteries that are approved to be used in FRC. So they have to be sealed lead acid batteries, right? Which is an older style battery, but they're batteries that don't blow up. We cannot use lithium ion batteries. Oh, I would love a lithium ion battery in my robot because it would give me so much power. But again, we play bumper cars, right? What happens to a lithium ion battery that gets punctured? Yep, it turns into fireworks. Can you imagine how many high school gyms would let us compete on their fields if we have robots combusting on them? Yeah. There, you know how much that floor costs? Yeah, that's no high school gym's going to allow us to compete. Yeah, so we have to use safe products. So we have to use products that are approved. If you don't want to go through the process of figuring out what you can and cannot use, I suggest you use AndyMark. So AndyMark is a company run by Andy Baker. This company started off by trying to fill the need of supplying parts to all of the first teams, but they supply general robotic needs also. If you go into their electrical section, you will find not only chargers that will take that AC electricity and convert it into DC and charge up the battery, but you will find the batteries that are approved to be used. They do. If you elect to have the kit of parts, they do. They give you one battery, don't they? They give you one battery in the kit of parts. Yeah, I think they give you. Yep. I highly recommend you have at least 6 batteries for competition. The reason for the 6 number is it gives if you're going through a competition, you're going to be rotating through your batteries. By the time you get back to the first battery you used, it's been fully charged between all of your different competitions. So you need 6 in order to get a fully charged battery the next time you reuse that battery. Every match. And we use only new batteries every season. Yep. Every match you put on a new fully charged battery. Every season we buy all new batteries. So we buy 6 batteries every year. Just put that in your budget. You just have to have it. Because yeah. Well, see, the problem is most people are not storing them in their proper state. So if you're not using your batteries all the time, which they only have so many charge cycles and they start losing power. But if you're going to store your batteries, it has to be stored in a cool place at 80% charge, is how you store them. If, yeah.
I mean, Jonathan does like batteries and does all that.
Yeah, so they have to be in a cool place, not freezing and not hot, and they need to be at 80% is where you keep them stored.
So like right now, off season, summer, whatever, so they just, they can be like in school, but you want to make sure they're all like 80%
80% charge is where you want them to be. Yep. Now, we demo our robots often, even during the summer and off season. So we keep our batteries on the chargers, so they're kept at 100%. But that is, again, it's dramatically reducing their sustainability.
And when you store, not me to prolong the whole battery thing, do you do it on a shelf, do you have a cart, how do you guys do it?
Well, all of our old batteries go off to the side and are used for various projects as we go. But our pits, we have a portable pit that is also we use during build season, and there's actually a place literally we built for the batteries to sit with all the chargers mounted in place.
I've seen, I mean, we had Marsh built a toolbox, if you will, with all those scrapers in it.
Yep.
And we have actually purchased a new one and kind of retrofitted one of our old ones with a battery in it.
Yeah, that works. So there's actually one of the cool things about going to competition is looking at everybody else's pits and how they've built and organized them, right? There are some really great ones. There's several that I want to mimic ourselves. Ebersol and a previous mentor, Morgan Mead, actually built those pits, designed and built them. And they have lasted now for 4 seasons, which is incredible. I will tell you, there's one year we actually had a decent amount of funds, and we bought like nice, really big Husky tool chests and all that. Our students broke them all that year. So we had to build something that was student proof, and those have been actually really good for that. So having really large wheels on your tools is a must. And the reason is you may end up at one location unloading onto a bad asphalt or have to get over several bumps here and there. If you have small wheels, the wheels are either going to break or they're going to get stuck on something and your whole thing is going to tip over. Big wheels are a must. It's so much easier to get over thresholds. So you'll go to a lot of gyms that will have a big metal threshold you have to get over. And having small wheels means your students have to deadlift the entire system to get it over that threshold. So I do highly recommend that. Pit is one of the things that you have to plan during build season. Take a look, and going to Worlds, seeing like the world view of what a pit should be was so cool. We got so many ideas. Of course, we have more ideas than we have budget for, unfortunately. Yeah, but I think that's everyone, right? All right. Now let's talk about the FRC control software, right? This is part of our control system. It's the software we use to control it. This is the FRC driver station. The FRC driver station is the software that we run on our laptop to send commands to our robot. So our robot has a central brain that is used to actually command all the hardware devices. The FRC driver station is the piece of software that has been programmed for you to actually send your driver commands to that brain, so it knows what to do. I'm actually going to launch the driver station here. This is the driver station with a very familiar sound. Oh, and it's launching our shuffleboard. Hang on one second. So this driver station piece of software right here communicates with our robot and sends our output to our robot. We have the main station where we have the teleop period, the autonomous period, practice and testing that we can use even when we're not at a competition. So we can actually go to autonomous and practice our autonomous routines, and it will perform like it would perform on the field. We can go to teleop, which means it's going to be driven by our actual drivers. We can go into practice mode, and what nice is really nice, everyone should be using practice mode when they're practice driving. Because what will happen with drivers is they will get time dilation about how much time they have to complete a task when you're just in teleop mode. Like literally, there are times where they're just in teleop mode and they're practicing, and they're like, look, we completed this whole thing ourselves. Yeah, what you don't realize is you did all of that in over 5 minutes. The game's only 2.5 minutes long, so you didn't complete the whole thing, right? So you need to speed up. When you put it into practice mode, it'll run autonomous. Then it'll switch into teleop automatically, and they actually have it, and they get all of the sounds that they're used to with the game. So when you build your robot, it is very, very important that your drivers practice. The more practice they have, the better off they will be able to compete. We've seen in all sorts of competitions where we've seen poorly built robots who had unbelievable drivers. And because of that, they were great. And we've also seen absolutely astonishingly beautiful, well-built robots that look like they were not functional at all because they didn't have great drivers. And the only issue with that is they didn't get enough time to practice with it. This is actually a constant battle between Ebersol and I, because Ebersol's job as the head coach is to build a great robot to compete with. And my job is to make him hurry up so I can actually practice with it and program it. Because drivers can't drive it until it's actually built, right? So drivers don't have six weeks to practice with a robot. You're lucky if you have a week to 2 weeks to practice with your robot. And that practice time is why a lot of teams will choose the latest competitions possible, so they just have more time to practice. Because a great driver can drive anything. A great driver can drive anything. What launched with my driver station here is this shuffleboard. The shuffleboard is a interface that lets you connect and get feedback from the robot. So this is the shuffleboard that we actually used last year, and I think I altered this a little bit on our actual driver station. But we had our fisheye USB camera, which gave us vision of the field. We had the smartboard, the auto options, so they could choose. We had 9 different autos that we could do. We pretty much only did one auto last year because it was, for the most part, flawless. The auto balance, so they would always choose that one. It would get us our encoders, all of our detailed items. It would give us what commands were being executed at the time. We could also enable and disable our compressor based on our needs, our air compressor. And it showed us the field orientation of the robot. So what the robot saw as its straight and narrow. So we could make corrections if it was off. If for some reason it thought, that was north, we could actually make a correction. It's like, nope, that way is north. And we could tell it to correct itself if it had the wrong heading for some reason.
So you did all this?
Say that again?
The shuffleboard. Did you guys make that?
So the shuffleboard is included with your driver station. We specified what we wanted to show on it. Shuffleboard is all done for you. You don't have to program a shuffleboard. What you have to specify is what you want to be shown on the shuffleboard. So let's go back to the driver station. So in this driver station here, you have in the configuration, the little gear one, dashboard type. And these are the different dashboards. So if you don't do anything, by default, you're going to see this classic dashboard. This classic one right here.
Oh, yes.
Yep.
That's what I said.
That's the default one, which has there's very little you can do with this one. Very little you can alter with this one. But it shows you a lot of the basics of what's going on with your robot. They also have the smart dashboard, which is what the shuffleboard is actually built or based on. It's just expanded to be more usable. And they even have a remote system. So you can actually send that data to another system. Shuffleboard is probably one of the most used and most customizable system that you can use. So if you look at top teams, they're all using shuffleboard for their driver station, because we need to. And I will tell you, our drivers don't often look at the shuffleboard because they're paying attention to the field, unless they need to look down at the camera to get a better view if they have a block view or something to that sort. I will tell you, the person that uses the shuffleboard the most is me as the drive coach. So I can monitor the systems and know if something has gone wrong. Because I can look at the shuffleboard and see all of the details that are going on.
You set up your shuffleboard, so like my shuffleboard is blank.
It'll be blank.
You put the stuff on it that you need to do.
Correct, yes. And when we get to the advanced programming on session 3, I'll show you how to build a custom shuffleboard. So I'll let you guys dive into all of that. No. In here, you also see this diagnostic. The diagnostic will actually show you the status of everything as far as your robot is concerned. It is, especially for your drivers and driver coach, they need to know this system, okay? Because they can quickly diagnose what is going on by looking at the status of all of these different things. If the firewall's on, if the USB is connected, if FMS is connected, it shows you a lot of details right here. It also gives you the ability to reboot your robot. So if you're in the middle of a competition and your robot has suffered a fatal error, you can actually reboot it during competition by clicking the reboot. So you can actually get things back up and running again, right? That's if the issue isn't you lost power. If you lost power, you're just dead in the water. If your battery pops out during competition, there's nothing you can do. It's just dead in the water until that round's over. In the gear, we have where you have to configure your team number. So whatever your driver station is, you have to put your team number in here. Otherwise, it will not be able to talk to your robot. Okay? Your Robo Rio, the brains of your computer, you're going to configure with your team number. And your driver station has to be configured with the same team number. That way they know to talk to each other. Okay? If you don't have one of these things configured, it's not going to work. All right? On either end. If you want to run 2 robots at the same time, you can actually just create numbers. You can make the number that's on your Robo Rio whatever you want. And then put that same number in here, but that only works when you're in your own shop, right? When you get to competition, and this has happened to teams, they've gotten to competition and their robot, they can't control it anymore. And they start scrambling around asking for help, and it turns out that their Robo Rio wasn't configured with their team number. You have to have everything configured as your team number. Otherwise, it's not going to work during competition. Before every competition, they usually give you a moment to get on the field and connect to the field to make sure that your robot is talking to FMS and your driver station can talk to FMS. Always do this. Always. The only time you cannot do this, in fact, if you haven't even passed inspection, they will still let you take it onto the field to verify you can connect to FMS, okay? Because we've had competitions where people are maybe out of spec, and so they can't pass inspection. but they'll tell them, go get connected to the field, make sure that it's actually working. So we know you can work during competition. And basically what it's checking is making sure your driver station is configured correctly, and it's making sure your robot is configured correctly. If those two things are configured correctly, then your robot is configured correctly.
So FMS is field management.
Yes, field management system. FMS is the server that runs all of the robots. So during competition, your driver station is not controlling your robot. FMS is. And what you're doing is you're transmitting your information of your driver controls to the central computer, and the central computer is relaying those commands to your robot. But that gives FMS the ability of saying when autonomous starts, when teleop starts, and if I want to disable your robot, there's nothing you can do about it because you're no longer controlling your robot, FMS is. But it's relaying that data. An important fact, and it goes a little bit beyond this, if you have too much information flowing to your dashboard, you will actually hit a bandwidth limit because FMS has a 10 megabit bandwidth limit. A USB camera can take over 5 of that alone. You add in 3 cameras, you're now over your bandwidth, and you're going to have lag in camera images and lag in driver controls. There's nothing more frustrating. Our primary driver from last year is actually just joined us. There's nothing more frustrating than giving or telling your robot to drive straight, it does nothing, and then all of a sudden it starts driving straight all by itself. Well, it's because it's just now following the command you gave it. It was delayed because there was a delay.
So it's 10, you have
10
10 bandwidth,
megabits
10 megabit bandwidth limit
per robot. Yep. Now the problem is, and this is something that I'm sure FRC they're aware of the issue. I'm not sure they know exactly how to fix it, but when you're on one alliance, if someone is eating up their entire port of bandwidth, it can actually start affecting the other robots on that alliance. And it's not a field fault, no. They will not call a field fault. The only time they'll call a field fault is if the processing on FMS spikes, meaning that it can't relay the commands. FMS itself cannot relay the commands to the robot fast enough. They'll call a field fault for that. But if a robot was causing a problem, it's not a field fault.
What happens if the robot decides to put 4 cameras on there and you start getting lag problems because of their FMS bandwidth issues? Just don't think. That's what happens.
Well, they haven't yet, so. They put those bandwidth requirements in place because of the controllers they're using. So they need to update their system. I mean, we have gig and 10 gig networks that are decently cheap nowadays, but the FMS system that is there and running has been the FMS system that FRC has been running for at least the last 15 years or so. So it's kind of old technology. Yes. Yes, and I will tell you that I'm sure they are working on something, but there are so many, it's a lot of coding, and I'm sure there's lots of bugs. The last thing they want to do is introduce a new FMS that constantly crashes. So this FMS is decently stable. Yeah, yeah. So it's been running for quite a while. This exact system as it is.
Well, it was 10 years in my old school. And then I was 2 years off when I was in high school. So this will be my 15th.
15th year.
So
Yeah.
it's back when
I have not been part of FRC where they weren't using the RoboRio. So before the Robo Rio, they had a Rio. Yeah, it was a yeah C Rio. So yeah, they had an old Rio, and I'm assuming that they probably introduced this new FMS when they introduced the Robo Rio, is when they introduced that.
I just remember a lot of
Yeah.
I was going to say that it was such an issue last season that we're going to add how many cameras the robot has for a big inspection checklist. Because there were some teams that were like, yeah, we're going to run 3 line ones. So you see here, here, here. And like, oh, that's a really great idea. And then we got to field it. Like, no, that was really
The next tab is the USB. It's the controllers. So when you plug a game controller into your robot or your laptop, your driver station, so you can actually use it to control, it'll show all the USB controllers plugged in, and you can rearrange them. In fact, it was always part of our primary's job. Whenever we plugged into the field, she would go to this list and make sure that the right controller was on the right port, and she would rearrange it if it wasn't. I know our primary driver a couple years, or the previous year, forgot to do that once, and the robot was acting all weird, and they both realized all of a sudden that, holy crap, the controllers are switched, and they threw each other's controllers at each other and started driving with the other controller. It was it was you and Connor, so. So it was her fault then too. She learned her lesson back then, I guess. So that was one of the checklists that always happens right before the start of the match. So you make sure your controllers are on the right spot. But this has more functions. When you plug in can you grab me a game controller? Anyone, doesn't matter. When you plug in a game controller, it'll actually show you all of the accesses and all of the buttons. I really wish it would actually label the buttons. It does not, but it shows you all of them, so you can actually plug in a controller and see if the controller's functional. It's really nice. And you can use PlayStation controllers. You can use, is it wired? I need one with a wire, so I can actually plug it in. You can use PlayStation controllers, Xbox controllers, or joysticks, right? We have been using Xbox controllers for all of our games, largely because, because the generations that are driving now, that's the controllers they're used to. You give them one of the Logitech, flight control sticks, very usable, lots of commands, lots of buttons. None of them can use them very effectively. They just can't. You give them an Xbox controller. Thank you. You give them an Xbox controller, and they know where all the buttons are without even looking at the controller. They can just simply drive it. So I just got an Xbox controller. I'm gonna plug this guy in. And there it is. So it's popped up with an Xbox controller. And we have all of the different access. And we have, oh look, they label accesses, correct? And then all of the different buttons and the POV. So I can actually manipulate the controller and see the value of those items. In fact, when I push up, you notice that the y-axis goes to negative. So the controller itself is reversed. No, you're weird. No, it's not. Because of old people like you. So, I'm sorry, but I want to move forward, not climb a plane. But the reason it is reversed is because the original controllers were like for flight simulators and things like that. So pushing up makes you go up in a plane. But I can see all the values that are on, and when I push the buttons, it shows me that the buttons are working. And we have analog devices and we have digital devices on our controller. These bars are analog, meaning that the value goes between two values, -1, +1. It's an analog value, where a button is either on or off. Okay? So that means a trigger on an Xbox controller is actually an analog device. No, a bumper is a binary device. It's either on or off. So trigger is analog, button, yes. The triggers are actually click?
There are some like professional ones. Yeah. So you can set, so instead of having a range, like a dead space for firing, like a Call of Duty or
Oh, it has a configurable value to make it just a binary. Oh, like a PlayStation. The PlayStation has 2 buttons instead of triggers. Yeah, well, this Xbox controller is a trigger, and it's analog. PlayStation has 2 buttons that are binary, yes. Yes, absolutely. You can use, actually, most controllers you can use. You can even use really off-brand controllers. As long as it's recognized by Windows as a joystick. As long as Windows recognizes it, you can use it to control an FRC robot. We've even had a team, not us, I don't remember what team it was, that used a Guitar Hero guitar to control their robot.
So the secondary driver did that, and it was New York, Central New York, like I think it was Power Up, and it was back when they had good scale. So they had different settings for like the color buttons on the thing, and then I forgot what the strum was for, but they would use that as their secondary.
Now,
They used it pretty successfully.
yes, it was really cool. Not something I would have allowed on our team, but it was really cool. It was really cool to see. But so as long as Windows recognizes it as a joystick, you can use it. Yes.
Would you use like really, really old Nintendo, like 60, like those really old ones?
If you can plug it into Windows and Windows recognizes it as a joystick, yes. So there is a USB adapter for the NES that you can plug into an NES port and plug it into USB, and Windows recognizes it as a joystick. Now it's technically the little adapter cord that's doing that for you, because all the buttons, they're just binary buttons on the original. But yes, you can absolutely use that. There's only one rule. It has to be wired. You cannot use wireless controllers.
Why? Is it a limitation in programming?
It is a limitation in the rules of the game. No wireless communication at all
Somebody else could be controlling the robot.
from somewhere else. Yep. It has to be a wired controller.
There's also another reason we use joysticks. If we don't use joysticks and we use Xbox controllers, visualization on the field of the driver is always a hard thing to do. And joysticks limit you to the driver station, but the controller allows the driver to move around and get better visibility.
Yeah.
That's all we do.
One of the previous years, I actually had to grab our driver by the shirt and drag him back into our box because he couldn't see, and he wasn't doing it intentionally, but he went into the other driver box so he could see better. I'm like, no, get back into our box. But yes, having a good old traditional instead of a flight stick, I can actually get down low. I can go over here. I can move around a lot more. Last year, I saw our primary driver push our secondary driver off to the side so she could actually see what her angle was, which was funny. Nick was pretty easy to push over, so.
What's the
Yeah, you have. So, yes, you cannot. I'm not going to go into it anymore. Yes, you need to plug in to your system in order to communicate with your robot.
Anyways, start recording.
All right. Yep. So the one last thing I want to show you, and this is something that I knew existed, but I didn't know how it worked until last year. When you have a controller in place, every USB device has an ID, as long as it's plugged into the same port. it has an ID that's recorded in the system. So if you always plug the controllers into the same port, you can double click on the controller and it will get that underscore line. What that does is it locks that controller in that port will always be in that slot. You don't have to switch them. Right. But it only applies if you plug it into the same port. Because if you plug it into a different port in Windows, it actually gets a different ID at that point. All right? But it'll lock it so it's always there, it's always in place, which definitely comes in handy if something happens, your driver station rebooted in the middle of the match, or anything happens to that sort, it'll come back up the way it's supposed to. Now, it's not an excuse for not double checking. You should still double check to make sure it's there. Because it's very possible that the pit crew may have changed something in the middle of like looking at something. So always double check anyways, but it's an extra security measure. To lock it into place, double click on it. To unlock it, double click it, and it's now unlocked in that place. Okay. So if you plug in a controller and it doesn't see it, hit the little rescan button to rescan, but sometimes that won't work either. Sometimes you literally just have to unplug it and plug it back in again. Yeah. And then the last tab will show you the actual 12 volt, 5 volt, all of the different voltages and the comms and the transmission, your CAN metrics. So all of a sudden something goes bad or the robot's stuttering, you can actually go to this tab and see where your CAN utilization is. If it's peaked at 100, that's probably what's going on. You're getting delayed CAN messages because of some error. Rarely is there an issue with the bandwidth requirement of CAN. Most of the time it has to do more with the there being a loose or disconnected wire that's causing CAN issues. All right, that's the driver station. On the right side, you have all messages, warnings, and errors that are happening on the robot. If you click on this little thing here, it'll show you your battery and processing values. And then you can go side by side and see the warnings and those messages, the statuses. If you go up to the gear that's up the top, you can specify if you want to see errors and warnings. If you want to see errors, warnings, and prints, it gives you the ability to select what you want to see. Usually during a game, you just want to see errors. Otherwise, it just gets flooded with random things. You can also click on View Log File. When you go to View Log File, it's going to launch a separate application which will show you all the previous times the driver station was being operated. So you can see the entire match, the voltages, the signals, the delays of everything that's going on. So if you have an unexplained problem that you don't know what was going on, you can open up this dashboard and look at all of your values and see that, oh, look, I kept browning out on my battery the entire match. This might be a bad battery. There was one match where we had a few dips for some reason. And we actually found out after that match that the battery connector was coming loose. So the cable connecting to the battery was coming loose. And so we tightened that, and we went through and tightened all the bolts on all the batteries again. They're just from the competition wear, it just had come loose. We should have, retightened those at the beginning of every competition, but there's so many things we're doing. This one thing we left behind. This one, I can tell that it was running for a very long time. 8,387 seconds. That was a very long match. I'm sure that was just strictly driver practice the entire time. So they were just sitting there hammering away at the robot. But see, red here is our Robo Rio CPU usage. Packet loss is the orange. Latency is the green, and battery voltage is yellow. So here's our battery voltage. We're dipping down pretty low here, -8. So that's our stuff. And if you go to the event list, it'll show you all of the events that happen during that use. These are all the events. So you get detailed perspective of what was going on. There was actually a time where we were having a really rough time. Things were delayed, and I actually went into log and found out that, yes, our FMS traffic was quite delayed. By the time it was going back up to the FTC, no, not FTA, the FTA was coming to me to tell me the same thing. And we had to replay that match because there was an issue. All right.
That's not the only thing that causes delay.
No. No, your own computer can cause a delay, and anything that is happening on your end is not a field fault. So if it's something with your computer, it is not a field fault. So always, even if you have a fully charged battery, always plug in your laptop to power. There's one very specific reason for that. Does anyone by chance happen to know why you always plug it in when you're competing? Not you. What's your... Yeah, not too bad, not too bad. So the one thing is, if we have a fully charged battery, we're pretty good. But what? And but if I have a fully charged battery, it should last me at least 2.5 minutes.
Your battery can't actually power the power usage.
But it can. It's built for that, right? It's actually a fact about computers that most people don't know. When you're running on battery, your computer will step down its processing capabilities. So it runs longer on battery. So you want to plug your laptop in so it will spin up to its full performance. A laptop will only run on its full performance if it's plugged in. Yes? Yeah, it'll conserve battery power. Exactly. So you always want to plug your laptop in so it runs at its best performance. Very good. Anybody have any questions about, yes? Oh, horror story, okay.
Yeah, one time we were queued up for a match, and the kids come up to me and say, "Hey, our laptop is trying to update itself."
Oh, yes. Oh, no, it'll still update. Yes, when you go into competition season, I actually always set up all of our systems. We update everything, get everything perfectly running, make sure we have the current driver station, all of that is set up. Every year, I actually wipe our driver station and reinstall everything fresh because we've done lots of things to that driver station over the competition season, and I wanted it to be completely fresh and new. Run all of its updates, and then I will actually go into Windows services and disable the Windows Update service. So it can't even get out to do an update after that.
So your school lets you like completely wipe your devices?
We have devices specifically just for robotics.
That's what I was gonna ask, because we
Yes.
have two pretty old Hilda laptops that we use, our programmers use, and we use to run our robots that aren't tied to the school. And then we have, ample school laptops.
Yes.
Well, we can't, we can't wipe the school laptop.
Yeah.
But ours, yeah, and I don't know if we need to just, those laptops have been there for quite a while, and I'm not sure if we need to just go out and get new ones. And if there's a recommendation of like,
So I actually make Dave every 3 years buy a new laptop to be used as our primary driver station. Nothing else is used. It's only for driver station. And
Does it have a certain spec?
Well, I'm not sure if firmware does that with laptop.
yeah, we have different laptops for programming. You can put it on the same laptop. That's okay.
When you say programming laptop, you don't mean driver station.
No,
Separate
separate
thing.
things.
Brand new driver station laptop.
Yeah. And no, we don't get a new programming laptop every year. We get a new driver station every year, just because let's face it, these laptops get abused, right? They get dropped during competition. The ports get bent. Rachel, our primary driver, I have these little USB micro. Let me switch to the. So a lot of laptop devices you get nowadays don't have USB-A anymore. So I have these little devices that convert the A into a C. I've purchased I think about 10 of these. My son, Connor, who was the primary driver 2 years ago, probably broke 5 of them himself. And then Rachel broke, I think, 2. Yeah, she broke 2. She argues with me about it all the time. She's like, it's someone else that did that. But she would hand me a port where the port is all turned this way.
So,
It's always someone else's fault. Even though she's responsible for it.
Out of curiosity, right? So our laptops we purchased, right? But IT still had to go through and do all their school stuff on it, so we have no control over the actual software.
I cannot specify what your school policy is. I will tell you, if it's a Windows computer, I don't care what has been installed on it, you can wipe it and bring it back to its factory setting.
Which we've thought about going through this.
I'm not telling you to do that. I'm just saying that Windows makes it very easy to accomplish that task.
We might do something similar to that. Maybe get just a separate laptop for driving. But we can't download them because then we have the school's Wi-Fi password.
So a couple things. You need a laptop that is not connected to a domain. Because the last thing you want to do is you can only log into a Windows laptop that's connected to a network system so many times before it's required to be reconnected to the system to re-authenticate you. The last thing you want is to be at a competition and you can't get into your laptop. That would be very, very bad. So this needs to be a laptop that's not connected to anything. It is set up like a home PC that is not connected to any network. It is blank, ready to go. Okay, so that's the driver stations. Which I just showed you the driver station. I actually demoed it, so we're good there. Now we're actually going to get into the hardware of our entire control systems. I should actually have you present some of this. Yeah. Okay, first thing we're going to talk about is the RoboRio. The RoboRio is the brains of our computer, and there's actually 2 separate versions now. It is what actually does all of the actual everything is done by the RoboRio. The driver station on your computer is doing nothing but reading information and sending driver commands to the RoboRio. The RoboRio is the microcontroller that is actually processing and completing all tasks on that robot. So if it doesn't work, nothing will work, nothing at all. There is a version 1 and there's a version 2. Its whole purpose is to take inputs and then send outputs to all of the various devices and interfaces with our system. It also communicates with FMS or the driver station to communicate inputs and outputs from that also. So let's take a look at that. Here's the first RoboRio. This basically on this side of the RoboRio, we have the digital inputs and outputs. Digital meaning it's either on or off. Okay? So we would plug things like limit switches into digital inputs. So it's either on or it's off. Right? That's a digital input. DIO is digital input output. Okay? So it'll send a on or off, plus 5 volts or 0 volts. On the other side, we have PWM. PWM is a wave. It's an analog signaling system. It can receive analog signals or send analog signals. Old motor controllers actually use PWM, and a lot of things still to this day still use PWM as a motor control systems. A lot of electric motorcycles and stuff like that use PWM to tell the motor how fast you want it to spin. This is PWM. And you notice that it has port numbers. And this tells you what port that you would reference in code. So if I wanted to plug a limit switch into this port, I would reference digital port 0, digital port 1, so on and so forth. Pretty simple, right? We also have relay controls and analog controls. So analog gives me the ability to actually monitor something like a distance sensor, which can be anywhere from it's right up against me to it's really far away from me, right? It's an analog signal, like we talked about with our joysticks, where our joysticks had analog, -1 to 1 values, right? Anywhere in between, where digital is either on or off. This analog gives me the ability of reading a range. So if I were to use something like an ultrasonic sensor to measure distance from my robot to something, I would use the analog inputs for that. We also have power, where we supply power, and this is going to take in that 12 volts power from our battery. We have USB to connect to it and talk to it directly. We have, this is a USB-B. We have 2 USB-As that we can use to plug in flash drives, or we can actually plug in a USB camera and get camera vision. We have our network port that is the primary means of talking to our robot during competition when it's connected to the radio. We have an SPI and a MX port. These are for expansional devices. So we can actually take our RoboRio and we can expand upon it and add functionality. This particular device is called a NavX MX, and what it gives me the ability is measuring acceleration, G-forces, has a built-in gyro, so it actually knows where it is in space and time. So it gives us the ability to upgrade the functionality of what is capable. The nice thing about the MX is it actually gives me additional digital inputs and analog inputs that I can use for sensors. So it expands upon what's available on the board itself. Now, this is version 1, yes. It also has all of these status lights, so it can tell us where our robot is as far as booting up and all of those things. Our RSL is our light that we are required to have on a robot that tells us the status of the robot, whether it's enabled, whether it's powered on, or whether it's powered on or disabled. So it tells us where that is. Plugs into this, this guy down here, sorry. This light right down here. But we can also see this light right here is that same thing. It's showing us in the same place. So the mode, whether we have comms, whether it's connected to the radio, what the current status is, and if it has power. This is version 1. This is the version 2 of the RoboRio that is out now, which it specifies right here, version 2. The difference between this physically is it has an SD card slot on it. And the SD card slot can be used for storage, but also stores the image. Under the hood, on the other hand, this thing is twice as powerful. So it has the ability to perform far more calculations faster than the original did. So if you don't have one, absolutely get the new one. In fact, I don't think you can order the old one anymore. They're the same price, right? You're going to get a Robo Rio 2 if you buy one today. Say what? Salesman, yeah. Buy today, right now, for a low, low price of retail value. I will tell you that I have to give NI a lot of credit, considering these are high school teams, because you can buy a Robo Rio for industrial use, but they're close to $1,000 a piece. Network Instruments or National Instruments sells it to FRC teams for $400. So it's really great that they do that. They've also increased that these are faster USB ports also.
Now, when you say it has the SD card imaging, does that mean that, what does that mean?
So in previous boards, we would actually connect to the USB port and image the software onto the actual chip itself. In the newer generation, you image a card and then you insert the card into the box and the image exists on the card. But that gives it tons of additional storage, so we can actually have, we can write a lot more logs, a lot more details to the card for multiple different uses. And this one has a wire connected to its power port here. But it still has the same MX port, SPI port, a I2C port, and a RS-232. Different ways of communicating with other devices. I will tell you that the only two that we've used in robotics, our robotics, is the SPI and MX port are the only two ports we've used, expansion ports. But you can connect these other devices also. Really nice. But this is the Robo Rio. This is the brains of the computer, and this is everything that you're talking to and you're programming to, is this right here. The most important part of a robot. We always carry backups because we've had issues where something went wrong. Not to point fingers, but a lot of teams, the engineers will drill new holes into the robot right above the Robo Rio and short things out. So this magic conductive dust. No, they either work or they don't.
No, the test is open it up, there's four screws on the back, and the aluminum comes out, you figure out the problem.
Yeah.
And I know that we cover us and stuff, but I know that people swap around, go around.
Yes. So yeah, there was one Rio that died on us, one of these original Rios, at a competition, and when I took it out of the robot and shook it, I could hear, like, there was something. These should be quiet. They should not make any sound at all. There was something shaking inside of it. I'm like, what the heck? So yeah, we took these four screws out of the bottom, opened it up, and just this deluge of aluminum came out of the Robo Rio. So, yeah, there are like really fancy things you can 3D print and all of those things. Literally, the honest to goodness, the easiest thing is just to take electrical tape and tape over all of the ports you're not using.
There's also a lot of 3D prints out there for different painters for
If only I had just said that right before I said electrical tape, yeah. Yeah. But yeah, the thing that has worked the best, honestly, for us is taping over. Now, I will tell you, good practice is not a recommended practice, but it's a good practice. Whenever we get our robot to the point where we're not going to take it apart again, yeah, that's a situation that we have to talk about. We will actually hot glue our connector. So we'll plug the connector in and then put a spot of hot glue right between the connector and the Robo Rio. That way we can, that port won't pull out unless you pull away the hot glue. Now, keep in mind, I said you plug it in and then hot glue it. We had a student do that once, that actually put hot glue on the port and then put the thing on. Well, two things. Surprisingly, it worked, which I was surprised about. So the connector had a strong enough thing to push the hot glue away from the pin, so the two metal parts could make connection. The unfortunate part is we pulled all the pins out when we pulled the cable out. So yeah, we're not putting hot glue in the port. We're just gluing the adapter to the edge of the RoboRio, so it doesn't pull out. None. We keep recycling, yeah. No, we do not buy a new one every year. And that's one of the things is I know there are teams that do that and keep their robots completely intact. We do not have the luxury of doing that. Like I said, we have 2 fully functional robots from the 2 past years. But that is rare. The start of this next year, the robot from now 2 years ago at this point, that all the electronics are coming out of that. They're too expensive to have to repurchase every year. Yeah. So yes, yeah. Now there was several years we kept getting the kit of parts, so we have several of these older RoboRios because it came in the kit of parts, right? But we now we don't get the kit of parts. We get the voucher, and we use the voucher to buy the parts that we need. Yes, you can elect not to get the kit of parts, and you'll get a voucher instead. Last year too. Oh, you're a rookie. You needed the kit of parts then, yeah. You get more value out of the kit of parts than you do the voucher. So yeah, if you don't have anything, you get the kit of parts.
It's just better if you really have a lot.
Yes, yeah. If you already have all of this, if you have 2 RoboRios at that point, there's no reason to get the kit of parts for that purpose because you have the one you were going to use that year and a backup.
Technically, I think we did have some like years ago with like a different teacher, so we did have I think like a RoboRio, but it was like the old one.
Yeah, possibly, yeah. Now, I will tell you, FRC does a great job of supplying spare parts at competition. So if you ever run into a situation where one of your common components fails, they do have a spare cart over by Pit Admin that actually has spare parts, including RoboRios. Now, what they do not have is RoboRio 2. Right? Yes. They have the original RoboRios. So if you built your robot with a RoboRio 2, you're going to get from them a RoboRio 1. Now, in most cases, if you actually don't have a spare, you're probably a new team, and you're not really using really advanced programming techniques that you need a RoboRio 2 for. Like a RoboRio 2 is also really good at downgrading resolution of USB cameras, so you're not eating up your FMS data, transmitting it to the driver station. This is what the RoboRio is. And that was the RoboRio. All right, so the next thing that we want to talk about is our power distribution. So we talked about the RoboRio is the brains. We talked about our batteries, our FRC batteries, but there's tons of devices that run in a robot, and we need to get the power from that battery to all those devices. There are only 2 approved devices that you can use in FRC. You have the Rev Robotics PDH, and you have the CTRE's PDP. CTRE is the grandfather in this scenario. The PDH is the new kid on the block. So we know the CTRE is there and it's dependable and it's always worked, but the PDH gives us so much more capabilities and ease of access and use. But we're going to talk about what a power distribution is here. So a power distribution will take that voltage and that power from our battery and supply it safely to all the devices connected to our robot. So just like in a house where you're getting power from the street, it has a whole bunch of breakers to make sure that you're not overloading something and causing a fire. The power distribution is there to prevent fires in our robots. As long as we're using and wiring it properly. You can still cause a fire if you pull a whole bunch of amperage through a really small wire. So there's a whole bunch of guidelines on how that you are to wire your robot and how it's supposed to be done to make sure that we don't actually cause fires. These power distribution panels have breakers that we would add to them to specify how much power is allowed to actually transmit through that channel to the device that is connected to it. It also communicates with the RoboRio to tell you what its power draw and usage is. So we saw on the dashboard what our power draw is, what our voltage was. It's the power distribution panel that's actually measuring that for us. And it's communicating back to the RoboRio, hey, this is where our power is, this is what channels are using what power, this is our overall power usage. So that's what's actually communicating and giving us all of that information. This is a CTRE power distribution panel. So on a CTRE, we have all of these different channels. Oop, that one pulled apart. You can see the inside of a breaker in a second. They're very tight for a good reason. We don't want these popping out during competition. They actually make a puller to make it easier to pull them out too. But we have all of these different channels. On the CTRE, we actually have high amperage and low amperage sides. The pneumatics or the RoboRio's PDH, they're all high amperage. So you can actually plug any amp into any channel and then use whatever breaker that you need specifically for that channel. So this is where all of these different channels are. The breakers themselves are labeled of how much power is going to be allowed to transmit through that particular channel. Typically, you will use 40 amp breakers for drive motors. Then we can get down to, they have 30 amp and 20 amp and 10 amp breakers, depending on the load of the item that you are connecting to that channel. You want to size the breaker based on the wire and the device connected to it. So the size of the breaker needs to match the gauge of the wire and the item that is connected to the end of that. Like, I do not want to run a drive motor on a 20 amp breaker, because what's going to happen is that drive motor will often pull more than 20 amps and it will constantly flip that breaker off. It's an automatic switching breaker, meaning that if you overdraw, it'll disconnect power, and when it cools down, it'll reconnect the power. So that's where you can get sometimes a device that starts working, stops working, starts working, stops working. It might actually be drawing too much power. Question?
Yeah. For drive motors, I like to use Neos a lot, but I also use Neos in other places in the robot.
Neos?
I use them if it's not a drive motor with a 20 amp breaker, so like an arm movement.
So the answer is you can use any size breaker for any motor. But if you draw more than what the breaker will have, then you're in trouble. So yes, if I have a Neo, this is a brushless motor Neo. If I'm using a Neo, but I'm only ever using 20% power on this Neo, I can absolutely run with a 20 amp breaker. That's not a problem. Now, I will tell you though, even though you're using less power on the Neo, does not mean you can use a smaller gauge wire on a Neo. Per FRC rules, all drive motors must be 12 gauge wire, period. And that was on the diagram that we showed. We're going to talk about that more, but that was on the diagram we saw earlier. Even if I'm going to run this motor at 1% and never go over 1%, you still have to wire it as a 12 gauge. And the reason is this has the possibility of drawing more amps. So if I were to use a lower gauge, I run the risk of melting the wire and causing a fire. Question?
You keep saying drive motors, does that mean only for drive?
Drive motors is any motor that drives something. Yes. So no, it's not necessarily, drive motor doesn't mean it's just a drive motor. It's a motor that drives something. That's what a drive motor is. Yes. So that's a good distinction, actually. Yeah. Anything that's being driven.
Even if it's a mini,
Any motor is, all motors are drive motors. So any motor. Because they're all driving something. So we only want to populate the channels with breakers that has something plugged into it. It's a very important distinction. And like our Robo Rio, we want to tape over ports that are not being used. Can you imagine what would happen if I were to connect these two ports together with a piece of aluminum that fell in it? It could be bad. Especially because it's not a breaker, it's a piece of aluminum, and it's going to conduct power unlimited. If you have, this was always a joke, last minute breaker is always a paperclip. That's always just a joke. You never actually do that. Never do that, because you will catch fire. These breakers are there to keep the wire from overheating and catching fire. So use the proper breaker for the proper wire for the proper device. The FRC manual goes over what you should use, and most device manufacturers will tell you in their documentation what kind of breaker you should be using for the devices that you're plugging in. I actually know most of them by heart just because I'm used to wiring these things up. So on the sides are ports, and these are press-fitted Waco ports. And you put a flathead screwdriver on this side and lift it up, and it opens the port that we will find deep inside here. And then you simply put the bare wire into that port and release it. When we insert the wire into these ports, we want to make sure that the wire is seated as such that you can no longer see any actual metal. But that's a very fine balance. If you open this up all the way and you shove this wire deep inside of it, it may not clamp down on the wire. It may be clamped on some insulation. So you just need to play with it. Make sure you get the right distance of what you're cutting. And the right distance is what this line is right here, right? So you see this line? So if you put it here, that's where you need to cut it. Yeah. Yeah, that's what that line's there for. The PDH has one too, yeah. So you lift it up, insert the wire, and you want to see it that it's close like that. That's what you want to see. I never told you that, did I? Oh, sorry. It is, but it's also the distance you need to cut. Yeah, it's both.
It's both?
It's both.
I thought it was the negative too, so that's a good thing. You were wrong.
Yeah, it's both. The reason they placed it is to get the depth. Yeah. Huh?
The negative is lower than the positive side.
Yeah, because this is the distance that they want you to strip the wire to. So you basically insert, red goes to red, black goes to black. Okay? Now the colors matter. So red always goes to red, black always goes to black. Because when we're working with electrical components, the direction of flow of electricity matters, right? Now you'll notice on this end, it's got this green and white. This is actually, this is a CAN motor controller, so it's operated using communication through the CAN bus. But this has a negative and a minus. The benefit to this is I, on a motor, can actually flip them when I'm using a brushed motor. And flipping them just makes them spin in the opposite direction. So I don't have to adjust it via code, right? And we'll talk about this in more depth, on a brushed motor, it actually has 3 control wires. And they have to be connected to the correct 3 control wires. What? Yeah, what did I say? Brushed. Sorry, this is a brushless motor. These have the same torque, but this one weighs less than half and uses less power. These are practically indestructible, but they're dumb motors. These are smart motors, and we can do really fancy things with these guys. We'll talk about that in more depth soon. But once we have input all of our stuff into our system, this is where all of our devices are powered from. On the back end of our PDH, we will actually have connectors here for the the PCM, the voltage regulators, and our controller. So we are actually plugging the power cables from our RoboRio go to the red and black of the controller ports on our power system. So we just simply push that little connector down and we can push that wire in, and that is how we power our RoboRio. If we have a pneumatics controller and we're going to control pneumatics, pneumatics has a power port, or as a voltage in, and that would plug into one of these secondary devices. You have one that you can plug into your voltage regulator and one to plug into your pneumatics controller. These are where those go, and they have their automatic 10 amp for the RoboRio and 20 amp breakers for the secondary devices. Now that is how we wire it per our FRC rules. But we can use additional pneumatics controllers if we want to. We can use additional voltage regulators. They would just plug into one of these ports over here. Your RoboRio, though, must be plugged in here. This particular port is well protected and isolated from all of these other ports, because the thing that has to have as much stable power as possible is the thing running our robot. So this port was specifically designed to keep this thing running. Make sense? Now, there's also a PDH, and that again is the Robotics version. It works and is much nicer personally from my own personal. Now we know the CTRE is rock solid, right? We've been using it in robotics, FRC robotics for 15 years. It's been quite a while. Ever since I know, for at least ever since we've had the RoboRio, we've been using this. This thing, it just works. Never has a problem. I've never once, not once in my entire career in robotics, ever had a problem with the CTRE. The Rev Robotics, I have had a problem with that one, but it's a brand new product and they probably had to work out some of the bugs in it. But it is so much easier to work with. For one, instead of having this have a specialized small flathead screwdriver to shove in just the right angle, just to lift up the port so you can stick in the cable, the Rev Robotics one has these Wago levers. So you simply lift up the lever, put the cable in, and push the lever back down. So much easier. So much easier. Including the battery connection. I actually did not show that. Let me show that real quick. The business end of our PDH here is where the battery connects. So the big 6 gauge wires that come from the battery in the main breaker connect here. And then from there, it distributes the power to the rest of the devices. So this is the business end of our battery, where all that amperage and all that voltage is coming in. The Rev Robotics has that same port, but it, again, is a lever port. So we can actually put it up, just put the cable in, close it. The CTRE is a bolt. So you have to actually put an end on it, crimp down on it, and then screw it down. I have seen robots. We've, fortunately, knock on wood, have never had that problem. Well, at this point, we're not going to use the CTRE. We're going to only use the Rev Robotics. But I have seen teams, we've never had this problem, but I've seen teams where the actual screws that were screwing down the battery connector were not torqued down, meaning they were tight, and have come loose and have caused brownouts and a whole bunch of things to teams' robots. We want to make sure that those are torqued down so they cannot wiggle their way out. The Rev Robotics uses a compression, so it is incredibly rare for it to wiggle out. Any cord I've seen that have worked its way out of a Rev power distribution hub, it's because they didn't insert it fully into the hub. So you want to make sure it's fully seated, and then you close the lever. It's a continuous pressure, so even if the cable through the competition starts to deform, it just continually compresses it. So it can deform and still not lose its connection, which is really, really good design. They have the same ports where you plug in your Robo Rio and your additional other devices into the side, just like we saw on the bottom of the CTRE system. The extra benefit about the Rev Robotics hub is it actually has a digital display right on the front that actually tells you the voltage of the battery. I have actually, in competition, realized that we had an old battery in when we turned the robot on, and it was showing 11 volts. So I knew right away a freshly 100% charged battery should show about 13 volts. So I knew we had an old battery in that was probably not going to last us the competition or that match. So I had our tech go grab we usually carry 2 batteries with us, go grab the other battery from the cart, and we took this battery out and put a new battery in. So even without even starting the match, I knew I had a problem right from the get-go. That's a huge advantage over the older system. Because with the older system, it's going to show me I have low voltage when I got back to the driver's station. But I've already left the field, and it's possible the referee has closed the gate on me, and I cannot get back to the robot. So having that digital meter right on it is really great to see where the voltage is of the battery coming in. Do you guys have any questions about power distribution? All right. Just demoed that. Next, we have the voltage regulator, which I actually could not find one. I couldn't find any of our spares. None of our spare electronic components has a voltage regulator in it. I don't know where they all went. You what? Oh, yeah. So the voltage regulator, so again, we're getting 12 volts from our battery, right? Not all electronics use 12 volts. Some electronics use 5 volts. But that's not its only purpose. So not only does this have a 12 volt rail, so it takes the voltage in from the battery, which is 12 volts, and will give you a 12 volt rail. It also gives you a 5 volt rail. So you can plug in 5 volt devices. Now, we always use a voltage regulator. No robot should exist without a voltage regulator. And there's 2 different types. But the main reason is for this guy. This is our radios that we use to actually talk to our robot during competition and when we're at home. These radios are very, very sensitive to power. And if this is not working, you know what's not working on the field? Your robot's not working. It's sitting there, it's powered on, but I can't talk to it. This may have lost power. Yeah. One small brownout will take your robot out of the competition for 30 seconds. because it takes 30 seconds for this thing to reboot. That's huge. Because of that, we have these voltage regulators. This voltage regulator, its sole purpose in life is to buffer the power. Built into a voltage regulator are devices called capacitors. And capacitors are like micro batteries. It stores enough power to survive brownouts, because we don't want that radio to lose power. So we always plug our radio into the 12 volts, because our radio is 12 volt, into the 12 volt 2 amp rail on a voltage regulator, so the radio can survive dips in power. Because if we have a driver that is pushing the robot hard, your voltage is going to drop even if you have a fully charged battery, period. If enough device, especially if you're running swerve. If you're running swerve, you're running 8 motors really hard at the same time, your voltage can dip down to that danger zone. And if that happens, your radio reboots. So we use the voltage regulators to buffer those times when it doesn't have enough voltage coming from the supply.
Now, do you plug everything into that? So if I had a limit switch, would I plug everything in?
Nope, because the limit switch doesn't need, it only uses voltage for detection, not running. So we don't need, the only thing we would plug into this is anything that is voltage sensitive, or I need 5 volts to power it.
But you can get 5 volts.
The power distribution panel only gives you 12.
So anything.
Anything that needs 5 volts, I'm going to use a voltage regulator for. Yes, if you have 5 volt LEDs. But I would highly recommend use 12 volt LEDs on your robot, so you do not have to worry about needing a voltage regulator. Use 12 volt LEDs.
They don't need a separate one. Like if you were using 12 volt LEDs, you use the same voltage regulator that you use for your radio?
So the technical answer is yes, but the capacitors that are inside of their voltage regulator, everything is going to be buffered by that. So it is the recommended practice that the only thing you have at least one voltage regulator that does nothing but power your radio. That is the recommended practice. And you can have multiple voltage regulators in your robot. Yes?
If I have multiple ones, where do I plug them in?
I actually talked about that already. If you had an additional voltage regulator, you're going to plug it into one of the additional ports available. Now, I grabbed one, but I don't know where I put it. The Robotics radio module. I don't know where I put it. I'll talk about that in a second. There is a Robotics radio power module. What it is basically this 12 volts rail. It is this 12 volt rail through with the buffers, and it's built strictly for making sure that radio doesn't reboot. If we go to the manual again, this new picture for this year actually shows the radio module right here. This is the radio module. I know I had one up here.
So
I thought I had one up here.
so that's new instead of the voltage regulator.
So instead of the voltage regulator, you can use this, and this will actually power your radio. If you really want to be secure, you can actually use both. Yes, so you can actually use this, the Rev Robotics radio power module powers the radio through something called PoE, power over Ethernet. So it powers it through the network cable. But it has buffers to make sure you don't have voltage drop. And I've seen teams that have such bad luck with their radio rebooting that they also use a voltage regulator and plug it into the barrel jack on the device also. So we have a PoE network port that we can plug in and power the radio that way. And we also have a barrel jack that we can use to power the radio. And I've seen teams where they've actually powered it through a Rev Robotics here and also powered it through the barrel jack. Thank you. You do them both. So here is a Rev Robotics radio power module. So I'd actually run the 12 volt here. It has modules to protect it, and then it will output the PoE to the radio. And they literally label it for you. This goes to the Robo Rio, this goes to the radio. Do not plug it in backwards. It would be very bad. They came out a couple years ago. Yeah, they came out a couple years ago. But I have seen, as stated, I've seen teams use both because they've had such bad issues with their radio rebooting. But that's what your voltage regulator is for. Okay? Now, it's not in the rules that you have to use it. It is a recommended practice. Right? You can still compete without doing it. But if your robot keeps dying on the field during competition, are you going to be picked in finals? No. Right? So we want to make sure we have nice, stable power. Anyone have any questions about voltage regulators? All right. The next part is control systems, controllers. So we have drive controllers. So those two objects you see on the left here, this is a CTR E drive controller. And then we have a Rev Robotics drive controller. Now I'm going to pull up the camera here. The Rev Robotics drive controller is built to operate brushless or brushed motors. You can either use this controller to control both. So we have the power lines that would connect to our power distribution panels on the end. And then we have the power lines that connect to the motors. So if I want to drive an older brushed motor, this is a SIM brush motor. We have two wires that come out of a SIM motor. I would use the black and red wires coming from the controller, and I configure the controller through software to control a brushed motor. And this is not used for anything at that point. Or I can configure this to drive a brushless motor, and I would connect the color wires to the color wires. So I will tell you, as a team, we have a big case of used SIM motors, and we haven't purchased a SIM motor in 5 years. Yeah, we don't use them either. They're actually good motors. They are very good motors. They're high torque. They're practically indestructible. They get very hot and they wear down really fast. So it is possible with a SIM motor, if it's a SIM motor that's being driven really hard, its torque output will be less by the end of competition. And what I mean, end of competition season. It'll last a competition just fine, unless you're burning through it. It'll last through a competition fine, but by the end of competition season, you'll actually have less torque on a SIM because it is a wear motor. Meaning, the reason these are called brushed is they actually have a copper brush inside that's making electrical contact with one of these cables to the actual shaft on the motor. And the electricity flows through that motor, through that brush. And that brush is rubbing on the shaft. So metal rubbing against metal, what's going to happen? It's going to wear out through just normal friction, right? So brushed motors wear out. We have a whole bin of these that we don't use for anything other than the main reason we keep them around is we can run them by. It's not recommended, and I'm not recommending you do this. You can just connect this directly to a 12-volt battery and run it. You don't need a controller, but it's going to run at full power. You can't vary the speed. It's running at full power, right? So it's a great way for students to test an intake if they didn't have anything else or something like that to run. That is not a recommendation. That can be very, very dangerous. So don't do it. But it's possible with a brushed motor. You cannot do that with a brushless motor. We actually did have a mentor burn one out trying that. You cannot do that with a brushless motor. So this controller right here is made only for brushless motors and only has 2 wires coming out of it. You know if it can do one or both by the number of wires coming out to it. Okay? If there's only 2 wires coming out of it, it can only do a brushed motor. Victors are these are Talons, SRXs, but there's also Victors. There's a whole bunch of different motor controllers that you can use. Rev is pretty much all we use on our team, largely due to the fact that we have a lot of experience with them, but we also have a decent stockpile of them too. So we use Revs for most of our stuff. Revs, in combination with their motor, their Neo motor, has these built-in encoders that gives us lots of information about what's going on with the motor, even including what the temperature of the motor is. So we know if we're pushing a motor too hard. And it has the 3 wires, so we know that it can control a brushless motor. These are drive controllers, and we use these to drive motors. Okay? Drive controllers. Next thing we have here is the Rev Pneumatics module. Well, actually, there's 2 different kinds. We have pneumatic controllers, and we have the Rev and the CTRE, 2 competing companies for these products, right? The reason that these are the products, these are the only ones you have a choice of. You can't just grab any pneumatics controller. It has to be something that works with RoboRio. So these are the 2 products that work with RoboRio. The Rev Pneumatics module is the new boy in town. So the CTRE is our standard. We've been using this. And the same with all the others. We have a voltage in. So we take our voltage in from our components, our PDH or PDP. And then we have all of these different ports here for the number of solenoids that it will support. So just by looking at this and these numbers, how many solenoids, and solenoids are the actual devices that actually make the pneumatics pistons move. How many solenoids will CTRE support? 0 through 7. So 8 total, right? 8 total. Now that's 8 total connections. If you have something like a double acting, you're going to use 2 of those for 1 cylinder. All right, 1 solenoid. So you can go down from there. On the bottom here, you will actually have the pressure switch and the compressor power. For FRC, you must power your compressor through the pneumatics controller. Even though it is a 12-volt compressor, you cannot plug your compressor into the PDH or the PDP. You have to plug it here into the compressor out. And then there's also a pressure switch. And there are 2 approved pressure switches that measure the pressure in our stored tanks, our stored pressure, and will turn the compressor on or off automatically based on the pressure of the switch. All of those things must be connected to use them. And at the top here, we have a selector to select whether we're using 12-volt solenoids or 24-volt solenoids. Most FRC teams, we're all going to use the 12-volt. That's the common one. So you're just going to leave it right where it is. You cannot mix them. They all have to be 12 or they all have to be 24. And again, you can run multiple pneumatics controllers. Okay? This one is the Robotics pneumatics hub. How many ports does it support? A little hard to see. It supports 16 devices, 16 solenoids. That's double what the other one will. And we have a built-in microchip that we can actually access with our computer and do a lot of things with. We have our voltage selector for what solenoid we're using. We have our compressor here. We have a either analog switch or a digital switch. And here it actually has a light on the compressor. It'll actually turn green when it's calling or trying to give power to the compressor. It's a great troubleshooting step to see, hey, why is the compressor not turning on? If this is green and the compressor's not running, your compressor has a cable issue or the compressor died. So it's a great, quick troubleshooting issue. Now, the great thing about the Rev is it has an analog switch. So the digital switch is the same as the digital pressure switch on the CTRE. But digital means what? We talked about that a little bit. What does digital mean? 0 or 1. It's either on or off, right? You either have 120 PSI or you don't. That's all it tells you. It won't tell you how much pressure is in those tanks. It'll just tell you you either have 120 or you don't. So the Revs module has an approved adapter that will give you an analog signal. An analog signal wasn't just 1 or 0, it was 0 through 1, right? Now we can actually measure the pressure in a tank. Really cool. So you can actually go through the match and actually see where you are. And if your power usage is really high and you're about to complete your end game and you know you have enough pressure in the tank and it's going to hurt you on end game if the compressor kicks on right there, because the compressor uses a lot of power, right? I can actually digitally say, don't turn the compressor on, even if it drops below this threshold, which is really great. And with this switch, I can specify my max and minimum pressure in my tanks. The CTRE automatically kicks on the compressor automatically based on this switch once it drops below 110 PSI or so. It'll automatically kick on the compressor. So you'll have a whole bunch of microbursts. Where if I'm not burning through that much air, I could use this guy and specify, I want you to turn on when the tanks drop below 80. Wait to a longer period for it to go. Especially if you can run the whole match without ever kicking off that compressor, that'd be awesome. Then you'll never have that power draw, which is really great. Next, let's talk about movement. So with movement, we have brushed or brushless motors, which we've already now talked about quite a bit. A brushless motor is a motor that actually spins using 3 magnetic axes. So it's actually forcing, it has different poles to pull or push magnets to make the motor spin. It does not have a physical on physical connection, which means it lasts longer. In fact, since we started using brushless motors, rarely, other than us abusing it, rarely have we ever had to switch out motors on any system that we've been using for it. When we've had to, it's because we've torqued or pulled out the shaft. That happened once, or broken it in some way. We haven't ever worn out a motor, so that's a huge benefit, and they're a lot lighter. Brushed motors, on the other hand, though, cost a quarter of as much. Brushed motors are very cheap, and they're durable. Well, they're still a lot cheaper than Rev.
Yeah, a sim motor is about 33 and a Neo is about 35.
Are you sure?
I'm not sure.
All right.
It's the speed controller that
Speed controllers, yeah, there is a big difference in the speed controller. Yeah, you can get dirt cheap brushed speed controllers for practically nothing. The speed controllers, the Spark Max Rev Robotics speed controller, I do believe is $80 a piece, somewhere around there.
So the Neo is 45.
Neo's $45, the Neo motor, $35. So $10 cheaper for a brushed motor. But considering what you get, I will never, I don't, in the foreseeable future, see using a sim ever again.
Plus we need to put more weight in the bottom.
I'd rather add a steel plate than a dumb motor. Now, there's an argument to be said that I can add encoders, I can add all of these things to a sim motor. But why do all of that and spend all that money on all these sensors when I can just buy a device that has them all built in? The Falcon. So I have not personally used a Falcon, but I am very interested in using a Falcon. The cool thing about a Falcon is the Falcons are very expensive, but the main reason they're so expensive is not only like the Neo motor has an encoder and all of these things built into it, the Falcon has the speed controller built into it also.
And that's why I was.
It also has a really nice spline system for the shaft. You can just interchange them, so you really take the shaft out, put another one in, and the spline, you can just hook it up to no keys, no press fits, no nothing.
Yep. There's also a rule change in FRC because of Falcons. So Falcons also have a pneumatic port. Because these motors, when you're pushing them really hard, can get very hot. And they changed the rules specifically for Falcons that the exhaust from our pneumatic system can be ported into a Falcon. So when your pneumatic system is exhausting, I can use that cool air to cool down my motors. The Falcon is $220. Wow.
So a Neo is 48 plus, how much is the
Neo's 45. Neo is 45. And the controller, I think, was 80. $90 for a speed controller. So Neos are still far cheaper than a Falcon, but $220 for a Falcon. I really want to play with the Falcon though, but whew, that's expensive. And I'll tell you, the benefit of the Falcon is also the disadvantage. If you start burning through your Falcon motor, you can't reuse the speed controller. It's being wasted also. So we have brushed and brushless motors, and those are the benefits and disadvantages between those two systems, and whatever system you use is really dependent on what your team is trying to accomplish. So our solution doesn't mean it's your solution. Another team's solution doesn't mean it's our solution, so on and so forth. You have to make the right choice for you guys. We also have servos. Servos, if you're familiar with FTC, you're very familiar with servos because we use a lot of servos in FTC. But servos are micro engines, micro motors that have a 180 or 360 degree turn radius. And it's built-in encoders and all of those things also, so it can actually turn to a specific point and turn back. The great thing about servos is they're incredibly accurate about getting to the angle you are calling for. The bad thing about them, they are not strong. You cannot do anything that has any torque on it. A servo cannot do that. Now, they make some servos that handle torque, but they're too expensive. It's actually a lot cheaper to buy a small Neo and a speed controller than it is to buy a high torque servo. So servos rarely find it onto our FRC robot. We did use a servo last year though. So last year, it's not on this robot now because we had to take it off because we broke it. But we actually had, when we went to the human player, there was 2 game pieces you could get, either a cube or a cone. And we actually had this selector, this circle on the front of our robot. It would actually spin and show a cube or a cone on the selector. So when it drove up to the human station, it would tell them what we wanted. And we used a servo for that. So very simple, low torque, but very accurate to spin to the right thing. That is when our driver actually pressed the button. Sorry, I'm making fun of our driver. She's here, so I'm making fun of her. Or the human player actually read what the sign said. I will tell you, as cool as it was mostly a talking piece in the end, because most of the time the human player would be staring at me and I'd be jumping, basically doing the equivalent of YMCA, for a game piece. Yeah. So they would be staring at me most of the time. But there are little things you can use on a robot, little actions to alter how your robot's performing, and you can use servos. Yes?
So there's 2 main ways that you can use servos. One is locking things in place to move something, to hold something in place. That's a big one. And the other one is not as prevalent anymore, but when you have multiple geared transmissions for your drivetrain, so it's just a top box, if you will, you either shift it with a piston or you shift it with a servo. And most teams just use pistons, but some teams have servos.
Well, and you have to use, you really, for the most part, you had to use pistons because you needed a lot of power to push a gear into place, where a servo does not have power.
No, the servo works the opposite way. So the spring pushes.
Right, but servos even have a hard time pulling against a spring. Yeah, I know. Servos are not good for anything except light duty work. You also have actuators. You can have electronic actuators or pneumatic actuators. Electronic actuators is basically a very small motor with a screw and a rod, and the motor will turn on and screw out a rod or screw in a rod. And that's a linear actuator. We actually bought a couple linear actuators once because we had a great idea of using it, but we didn't realize 2 things. Linear actuators of the size we are trying to use don't have much power, so they can't push or pull very hard, and they are really slow. They are very, very slow. So if you have a stroke action that you need to perform on your robot, you are actually much better off using pneumatics at that point. It's just naturally slow. Yeah. So those are the different type of devices we can use for movement in our robots. So actual electrical motor, and we have also pneumatic controls that we can use. And then I have actually a separate slide for pneumatics. I showed you those motors. The next thing are sensors. So we have our robot, it has its brains, we have its muscles for movement. Now we need to give it senses. So it can feel things, it can see things, and it can react to different things that are happening. We have encoders, and this is a Rev Robotics hex shaft encoder. We simply take that device, install it onto a hex shaft, and it's got encoder wires that come out and plug into a reader. And what that does is it reads the position of something. So we talked about our robot from last year. It has this arm that swings in, I think it was about 300-degree angle, 300 degrees from one side to the other. Well, in order for the robot to know where to move the arm to, it needs to know where it is. This is actually the sensor we have on that robot, this exact sensor. And that sensor actually looks at where that shaft is and knows where it needs to be moved to then. So again, we're trying to give information to our robot so it can understand the world, so it can react to the world. That sensor tells it where the arm is, so it knows what to do to move it to where it needs to be. We also have this NavX, and there's multiple different types of gyro boards that you can use. The NavX board is one of the most popular. It's also the most expensive. Gives us acceleration, velocity, gives us gyro on 3 different axes, and can use all of that information so the robot can understand not only where it was, but where it has been, and at what velocity and that it's getting to get where it's going. So it has a G-force sensor built into it also. But you don't have to use a NavX. We also have these that came out actually not too long ago. These bags, yeah. This is an FRC, literally a gyro built specifically for FRC, made by Analog Devices. It's an FRC gyro, and it has nothing but that 3-axis gyro built into it. It is really easy to use, and this is actually the gyro that we were using when we started last year. But we had to take it off and go back to our nav because WPI accidentally programmed a bug that broke these. They didn't work. So we had to switch to this, and eventually it fixed the bug, but at that point we had programmed everything to use this, so we didn't switch away from it. But as this device plugged into the MX port here, this gyro here plugs in at the top on the SPI port and just mounts right in place. It is a very, very good gyro and will suit most needs. And it's a lot cheaper than a NavX. If I wanted to, honestly, you can use both. Redundancy. Or it could also be a coding nightmare, one of the two. We also have limit switches. So a limit switch gives us the ability to detect if a piece of our robot has made it to its target. If our intake has come in all the way. If our intake has gone out all the way, right? Now, you think, well, it's like, why do I need that? I have drivers, right? What part of the game do you not have drivers? What part of the game do I not have drivers? Lunch. I have drivers at lunch. Autonomous. During autonomous, there aren't drivers driving the robot, right? There aren't drivers to say, hey, you're not actually out. You didn't make it all the way out. So how would our robot know if a piece has actually extended or not? We have to give the robot a sensor. A limit switch is that. A limit switch will tell our robot, keep running that motor this way until I detect the limit switch has activated. That's what limit switches are for. They're also safeties. We can actually use a limit switch to prevent our drivers from breaking the robot. where the drivers like extend the intake and they never let go of the button to extend the intake, we could actually use a limit switch to say, hey, obey the driver until you hit that limit switch, and then no, don't obey the driver anymore.
So we had to do that for telescoping, right? Because if they would go too far, it would just literally collapse. So we had to have an override for the sensor. There's no way the driver could do that from across the field.
Yep. There was actually one particular game for us that we are very heavy limit switched. It was Stronghold. So we had which I don't even know if you can use bungee cords anymore. You can use bungee cords still? Okay, all right. So we had a catapult to actually catapult a big foam ball up to the target. And we had a dumb brushed motor that didn't know when to stop, right? So we used actually several limit switches. Why do we use several? Because at first we only had one, it broke it, and it would burn out the motor. So we put several limit switches to have backups that it would tell the motor to stop pulling the winch back once it reached its firing position. So limit switches is what we can use in code to detect if a limit has been reached. That's what limit switches are for. Yes? Say that again? There are all sorts of encoders. If you really want to know what encoders there are a possibility of, there's one particular site I would suggest you go to. Can anyone guess what that is? AnyMark. So if you go on AnyMark, electrical, sensors, we are sponsored. These are all of the different sensors you can use on your robot. So if I go to all sensors, this is everything that you can use on your robot to sense something about your robot. They even have LiDAR that you can use on your robot. But all of these different sensors that you can use, here is an encoder that actually will screw onto the end cap of a sim motor and basically add an encoder to a sim motor. Lots of different. I actually like this particular one. This is actually a product that came out of literally the game Stronghold. Some team came up with this brilliant way of aligning their robot to the target. They attached a flashlight to their robot. And they knew they were centered if the flashlight was shining on the Lexan, right in the middle. So they knew, based on the center and the height of the light shining on their target, if they were at the right distance and right angle to fire. It was so smart that we copied them. And so did a whole bunch of teams. And it became actually a mainstay for a lot of teams of aligning their robots without using special vision code and all of that. Use the drivers. The drivers can adjust faster than most people, right? You can actually use the drivers to align. This is also where a lot of rules came out with blinding the alliance on the other side with their flashlights. That rule came out shortly after that also, because everyone started putting those flashlight targeting on their robots, and then it's pointed at right the perfect angle that it was blinding the drivers on the other side of the field.
There's a rival of ours who wears sunglasses when they show up, and whenever we would hit, like, sweep across the driver's station, they put the glasses on.
So they actually made a rule that you had to be able to turn the flashlight on and off. But they literally have, it's a flashlight with a focused beam lens that you can add to your robot. And it's a 12 volt, so it plugs right in. Yes? You can, so you cannot use visible light lasers. Yeah, because visible light lasers will damage eyes. So yeah, you cannot use. But there are distance sensors that, like LiDAR is a distance sensor using laser, right? That you can use, but it's not visible and it's not damaging to eyes. You can't use what? Why would you? Yes, you cannot use ultraviolet. You don't want to, cause harm to your alliance or your the opposite alliance either. I don't know. Every time I play with that team, I walk away with a suntan.
The last thing I want to say is the major rule change that he was talking about for the flashlight was you had to put it on a relay to be able to turn it on and off.
Yeah.
That was the big change.
But what my primary driver was poking me to state is you also have magnetic encoders. And I'm looking for one in here. Here's a magnetic encoder right here. This will allow you to attach a magnetic rod and have a sensor that detects the magnetic field of the magnet so you can detect where the motor is. Yes? Could be. These are very useful, and they do exactly what you need. So again, it's all focusing on where you want to go. I like using the Nitos because all of that's built into the motor, ready for me to use. Here we also we can see all of the different sensors that are available to us. Is there any other interesting ones to point out? That's not a sensor. You saw a lot of people use these voltage meters before the Rev Robotics pneumatics hub came out to give them that digital display. We have ultrasonic sensors here, measure distance, uses sound waves to measure distance for a robot. Yeah, that's pretty much it. So lots of different options as far as sensors for our system to allow our device to be able to see the world. And that's an ultrasonic sensor right there. So encoders give us the ability to see where a motor is. Gyros give us the ability to see the robot in general, what direction and what velocity it's driving in. Switches, specifically limit switches, give us the ability to see if an action has completed or not, meaning has a limit been reached or not. And it knows this by literally your device hitting this metal bar and compressing that button. When it compresses the button, it activates or closes the circuit, letting the robot know that the button has been pressed, meaning our device has swung all the way this way or swung all the way that way, however it may be. And then if we're measuring distance, we have ultrasonic or LiDAR or things like that that can measure the distance from my robot to an object, like the wall or something to the sort. And again, the whole reason that we need any of these items is so our robot can understand the world. If you want a really competitive robot in FRC, you have to automate as much as possible. The more tasks you can remove from your drivers, the more they can concentrate on the game than on, is the robot 2 inches too close to the field? So we got here, this is a limit switch. Here's a limit switch. So you can see a limit switch, this actually has 3 cables on this particular one. This is a VEX limit switch. We tend to use these VEX limit switches because we have like a whole bin of them. But you don't need to use these. You can buy the really, really dirt cheap ones from AnyMark, or a lot cheaper. And the reason this has 3 pins is one of these is normally open, one of these is normally closed. I don't remember which is which. You can use a voltmeter. But you can see it has a lever, and inside here it has a button that's being pushed. So it makes a little click sound when the button is pushed. So I know it's reached that limit. So if my intake is up here, and I need it to come all the way till it closes, when it hits that button, it knows to stop the motor, not let the motor proceed any further. Otherwise, I might push through and start breaking things. Cool? If you guys want to look at it. They're fun to play with too. I will sometimes, when the drivers are practicing, grab one of them. It's like a fidget toy. You just sit there and just fidget with it. Any questions about sensors? Now, when we get into the programming sessions, we're going to actually connect some of these up and actually play with them. Okay? Next, and in fact, I think this is the last part, is vision, being able to see. There are two different ways that we can actually see with our robot. We can use a USB camera with an off processor and use a system called GRIP. There is tons of documentation on how to use GRIP, and GRIP is open source and free for everyone to use. So you can actually do what Limelight does on your robot for practically nothing, if you have the time and effort to spend on it. Everybody else, we use Limelight. So Limelight was actually made by an FRC team. And Limelight is GRIP. It is all as a camera. It is actually a Raspberry Pi, I believe, all running in this pre-packaged, pre-made module that is very simple for someone to configure and use, even if they know nothing about vision tracking. It is a great product. So it has LEDs here that shine up and reflect off the targets. And it has a camera to look for those reflections. We communicate it via Ethernet like we do our other device, like our RoboRio does and our radio does. And it gets power via these power ports right here. So all you need to do to use Limelight is connect it to the additional port on your radio. So our radio here had two ports. This port is where we are plugging in our PoE, and we are plugging it into our RoboRio. Always use this port. By the way, I don't know if I stated that. Use this port. This is the port you use for your RoboRio. This will work, but does not, there's issues. For some reason, every so often, it drops comms. I don't know why. Someone explained it to me once, and I can't remember why that is now. Use this port. Use this port. So you're going to use this port for your RoboRio, and then you can plug your Limelight through another Ethernet into this port. Once you do that, you will have the ability to access the actual web interface. You just simply open up a web browser and you can access the web interface of this camera, and you can see the camera and use it as a camera if you want to. So if you don't want to do or mess around with any compression of data, changing of resolutions of USB camera, you can just simply use a Limelight camera. It is optimized to run on the FRC platform. It's ready to go.
When you guys look through like the controller thing with that, you can like actually see things.
You can see everything on the field, yes.
That's the one we got. It's like breaking and everything.
So it all depends on the camera, and you're gonna set low. You might want to set lower resolution if you're doing certain things. We hardly ever use, so the Limelight has these things called pipelines, where you can have different configurations on different areas, and you can programmatically change between pipelines as you're using it. I'm gonna actually step you, when we get to the advanced programming, I'm gonna show you how to do all of those things. But we would always configure at least two pipelines. One that actually had the camera as a regular camera, and may have run it at a higher resolution. And then one that would put it into targeting mode, would turn these lights on and then target what we're looking for. So you can change different pipelines as you go. Now, FRC is getting away from reflective tape. They're starting to move away from reflective tape. they're moving to what's called April tags. The new Limelight firmware supports April tags also. We have to go to the manual. It's like a QR code,
That's
yes.
what those things were in the last time.
Yes, yeah, that's true.
Yes, those things that were up on the game scoring and the human feed, those were April tags. So, and the nice thing about an April tag is it's a square. So if you're looking at a square at an angle, it distorts those lines. A computer with vision can calculate that distortion and know that I must be looking at it from over here. So it can determine where it is and how far back or forward it is by how much room it takes up on the image. It's really, really great engineering. And it's all done for you. So you do not have to be, Skynet and actually program all of these systems from scratch. Now, I've seen lots of teams that we built our own vision system. I'm like, all right, what kid lives in a basement and has not seen the light of day in the past 3 years? Because it's not an easy thing to learn. It's very hard. And the only students I've ever seen that have done it without extensive external help were kids like me when I grew up. Were kids that, never left their house. Their best friend was their computer. This makes that kind of technology available to all of us. Great product. And this is actually the Limelight 2. And you can see that this was actually from was it Power Up? No. Infinite Recharge. There's yellow dust all over the green lights. There's yellow dust all over all of this because as we were shooting off the ball during the game itself, as you were shooting off these big yellow balls. Yeah, right above, right under the shooter, right? Yeah, right under the shooter. No, it was above the shooter. So yeah, it would be pixie dusted with yellow dust, and we'd have to clean it off after every competition. You can see it's still pixie dust in here. That's Limelight, and it's great for showing you vision. Limelight itself also has extensive documentation and instructions on how to use it. And if you subscribe to forums like Chief Delphi, which is an exclusively FIRST billboard for discussion and questions when it comes to FIRST, everyone every year always posts their configuration files for Limelight. So they can just share it with others. These are the settings that worked for us. Doesn't mean you'll have to alter them based on, again, where you place the camera. You'll have to adjust the settings, but the targeting information all works. But Limelight makes it very easy for you to do it yourself too. Phenomenal product and so good. When you want to know if a product is good, look at how many robots are using it, then you know. I would say probably more than 50% of the robots all use this. Their support is really good too. We had a Limelight that just died in the middle of a competition. Lucky for us, we bring backups, so we bought 2. So we put the backup on, but we sent the old one to Limelight and they sent us a replacement. So they're pretty good about supporting their products too. And that's what we use for vision. Yes? Same with RoboRios. Yes, National Instruments. We had a RoboRio 2 where the SD card slot failed in, and National Instruments actually just mailed us a new one. So powering it all up. Now we've talked about all of those different components. We got to wire it all up. The important thing, the most important thing of all those things is to make sure you're using the right wire gauge. Your batteries can only use 6 gauge wire. Now, it is always legal to use a bigger wire than is required. You cannot use a smaller wire. If you want to use 6-gauge wire to wire up all your motor controllers, you absolutely can. I'm telling you that would be a nightmare and a lot of weight, but you absolutely can. But let me start with this part, the part that confuses everyone. The bigger the wire, the smaller the number is. The bigger the number, the smaller the wire. That's literally how it works. And in fact, they do get to wires that are even bigger than 0. So you know what they do? 0, 0 is the next step up from that. I'm sure there is a reasoning behind it, but that is the way it works. The biggest wire that you need in your robot is a 6-gauge wire. And that's going to connect your battery to your main breaker to your power distribution hub. Then from there, we have 12-gauge wire. What do you think a 12-gauge wire plugs into? What's the next biggest power draw do you think is on a robot? Or motors, right? So yeah, so you're going to use a 12-gauge wire, and that's what gauge these wires are, okay? You're using 12-gauge wire for all of your motors. Then we got 18, 22, 24, all the way down to 28. Is the different size wires that we can use. That diagram, this is actually the original diagram. The website currently has the updated diagram. This is the original diagram where it shows all of our devices that are in our system and the wire sizes you should be using for them. This is the God when it comes to wiring your robot. And it shows you where everything is supposed to plug in. So here we have our Robo-Rio that we've already talked about, and we can see this gauge wire here. If we go up to the chart, I can actually see what size wire that is. And in fact, if you look close at one of the areas, it'll actually show you what that wire gauge is. So this is 22-gauge wire. I need to use 22-gauge wire from the Robo-Rio, and it plugs into the controller port on our PDP. Then I have a voltage regulator plugged into that second port, and a pneumatics controller plugged into the next port. And it's again showing us the size wire. See how thick this wire is? What size wire is this? 6-gauge, right? You have to use 6-gauge.
So it was once normal to use PoE and jack.
Yes. And there's a lot of people that still do it this way because they're so nervous about losing power to the radio. So because if you unplug a network jack and plug it in over and over and over and over and over again, it can actually start to make the port or the jack itself loose. Yes. Is it okay to hot glue? Not only is it okay, I recommend you hot gluing everything in place. Again, you're not going to put hot glue in the port. You're going to plug it in and hot glue the outside of it. Now, when it comes to a radio, don't hot glue it while you're in your shop. Because when you get to competition, the very first thing that one of your programmers need to do is take the radio out of the robot and go get it programmed for that competition. Because what they're going to do is put a special Wi-Fi configuration with an encryption key on that device for that competition. So if you hot glue everything in place while you're in the shop, you gotta pull all that hot glue off so you can take it out of the robot so you can go program it. But as soon as you're done and you've programmed it for that competition, you put it back in your robot, what should you do? Hot glue those ports in place. Hot glue those ports in place. So here we can see, yes, this is being double powered. Again, plugged into the 12 volt of our system here. Now this actually has a digital sensor plugged into the voltage regulator also. This is not recommended practice. If you're using the voltage regulator, you should have the only thing that should be plugged into it is your radio. The reason for that is those capacitors again. I want all of the power in those capacitors to back up the power of the radio. So keep following along. We see our motor controllers, and what gauge wire are these guys using? Our motor controllers. Yeah, it's using 12, right? So we're using 12 gauge wire to connect those together. And going out and going to actual motors, what size wire do you think that should be too? Doesn't show in the diagram, but it should be 12 gauge wire also. Now, a lot of inspectors will be able to look at your wire and know what it is, but your wire should be wire that has its gauge labeled all along the entire length of the wire. And in most good wires, will have labels on them. So here I can see 12 gauge wire. So the wires are labeled so they know that the wire you're using is compliant. You cannot tell what a gauge wire is by looking at its outside. And the reason for that is the higher the voltage of the wire, the thicker the insulation will be. The insulation is not the gauge of the wire. The wire is the gauge of the wire. So just by looking at a really thick cable doesn't mean it's a 6 gauge cable. It could be a cable with a very high insulated, it could be highly insulated. So that's why we have these labels on them, so we know what the gauge of the wire inside the insulation is. We have in the past gotten wire donated to us from people, and we didn't actually know what the gauge of the wire was because it did not have a label on it. Now, there are devices you can buy to strip the wire and then you can gauge the wire itself. But the problem with doing that is when you get to an inspector doesn't have a wire gauge system. And they may question your wire. Now, in the end, will you get someone that says, yeah, they're okay? Probably, but you're spending all that time trying to get inspected and approved. If your wires are labeled, you never will have a problem. Here we have our pneumatics, and we have our compressor plugged in, our pressure switch plugged in, and we have our solenoids all plugged in. The last part of all of this is connecting our communication bus. So the RoboRio uses what's called a CAN bus. CAN bus is a networking system that was built to manage cars. CAN bus is what we literally use in cars. We also use it in our robots. So it's what allows the different devices to talk together. So the CAN bus works like this. Our starting point of our CAN bus is our RoboRio. It's really the one that wants to talk to everybody. We go from our RoboRio, if we have a pneumatics, into the pneumatics controller. From the pneumatics controller, we go to our drive, all of our other devices. Anything else in our system that uses CAN, we go to all of those devices, and it chains, right? It goes from one to another. And then we end in our power distribution panel. That's where we end those wires. Now, all of these systems use a very standard green and yellow. So you can just connect your green wire. It does not have to be green and yellow wire though. It can actually be whatever color you want. But just know when you're plugging from one thing to another, what you've considered to be one or another. For a long time, we had this blue and white wire that we actually used in our systems. So we had to remember that we considered the blue to be the green and the white to be the yellow, which is perfectly fine, perfectly legal. But you got to make sure you plug it. Because if you take your CAN bus and you actually plug them in backwards, it kills your CAN bus. So it has to be plugged in correctly. Now, this is the official and recommended way to wire your CAN bus. But I was inspired by Robotics one year. Sham Robotics showed me a new way of wiring, and I thought that can't be legal. This is how FRC says to do it. Technically, there isn't a standard required for wiring your CAN bus. From that day forward, Sham Robotics taught me to actually wire my entire CAN bus in a star format, meaning all of the devices that use CAN all wired to one bus, one connection point. This is the benefit of that. Remember, we're talking to and commanding all of these devices through that CAN bus. If something happens and this wire right here gets cut, that means my Robo Rio is fine, right? It's the brains. Pneumatic's fine because that wire is still okay. This motor is okay, but everything after that is now dead and won't work. This one wire comes out, everything after that device no longer works. So I can lose my entire drivetrain. I've actually had where we didn't wire like that once in that robot over there, where we actually lost we only had the right drive motors and nothing after that. Because the wire that went from one side of the robot to the other side of the robot got snagged and ripped out. And every device after that could no longer talk and we could no longer send commands to. So our robot was effectively dead in the water. We always had the policy too, because if out of all else things, if everything on the robot breaks, I need the drive system to still work, right? I need it to be able to drive it, because if I can't run any of the accessories on my robot, at least I can play defense. Well, if you lose one side of your drive motors, you can't do that either. You can just spin in circles. That's what you can do. Spin in circles. And I tell you, we've had every so often where robots have failed, and they're like, well, I'll just sit here. I'm like, no, stop that. You might break something else. Just leave. Just let it sit. We actually, at a regional competition, lost one side of our drivetrain. But the wheels had enough spin that he was able to inch his way like this all the way to the end game. And we almost had it. If he had just left it, she would have been able to climb, and we would have actually been able to climb with one side of our drivetrain. But he tried to get it closer, and it turned too much, and we could not get it back. We're like, ah. And then so we now, following the brilliant idea from Sham Robotics, wire it as a star topology. We home run all of the CAN wires back to one spot. So not one device breaking will disable all of the other functionality of our robot. That's how we do it now. And I will show you this on our actual robot when we get over there. This is our system. Here we can see our limit switch is wired to the digital I/O. Why would I wire a limit switch to the digital port? It's either on or off, right? The limit switch is on or off, so that's a digital input. A distance sensor. Why would I would wire that to an analog. Why would I wire a distance sensor to an analog? Yeah, I don't want my distance sensor to be my airbag in my car, right? That has a distance sensor where it says, yep, you hit something, right? I want to be able to know before I actually hit it that I need to apply the brakes, not after I hit it, right? So that's where we use the analogs, because it gives me a range to actually work with. Does that make sense to all of you guys? So main breaker is a 120 amp breaker. I have not met a single team who I've ever seen blown their main breaker, meaning all of the devices inside their robot collectively drew more than 120 amps continuously. If you're drawing that much amperage, you literally shorted a big wire onto something. is what caused that problem. And that flips off, so again, robot doesn't burn up. Connects to the battery, connects to the ports on our power distribution panel. Then we have our motor that plug in and get the proper sized breaker for the device that we are powering. We are powering a motor, the max breaker we can use is a 40 amp. And uses a 12 gauge wire, 12 gauge wires. Pneumatic system uses 18 gauge wire, both for its voltage in and its power cable going to the compressor. And it uses a signal wire for the pressure switch, which is I think 18 gauge for the, 22 gauge for the pressure switch. But our pneumatic system itself, the pneumatic controller and the compressor will use 18 gauge wire. Our voltage regulator, which we'll use for our radio, will use, again, 18 gauge wire to go from the PDP to the voltage regulator itself. We use 22 gauge when we're going from our Robo Rio power to our PDP is 22 gauge wire. And then we have our communications. So our robot signal light plugs into the RSL and plugs into the robot signal. Now, when you wire this up, it's all in the documentation. So again, always look at the documentation. But you have to actually jump pin 1 and pin 3 together for it to operate for use with our systems. If you do not have that jumper in there, it reverses. When it's disabled, it blinks, I believe it is. When it's disabled, it blinks. And when it's enabled, it turns off. Something to the sort. It works not in any way that you're expecting. I remember that I was actually inspecting a robot. They didn't have the jumper in there. And I'm like, disable your robot. They're like, it is. I'm like, no, it's enabled. Disable your robot. They're like, it is. I'm like, I'm telling you, it's not. It's enabled right now. And they turned the laptop around, and I'm like, it is disabled. What is going on? And I found out that they didn't actually wire their RSL together correctly. So make sure that it's wired correctly. Yes? Yes. It shows the correct thing. It has something to do with the wiring of this actual device when you don't jump those wires together. So, no, the Robo Rio's RSL light on the Robo Rio shows correctly. The external light, which has to be visible so everyone can see what's going on, and that light tells you a lot of things, by the way. That light tells you if it's disabled, if the robot has power, if the robot's enabled, or the robot's browning out. It tells you all of those things. So, how do I know if the robot has power? Is the light off? If the light is off, well, either it's unplugged or it doesn't have power. It lost power. So if your robot's competing on the field and then all of a sudden that RSL light goes black, you lost power. So either your breaker went off, your cable came unplugged, or your battery got unplugged. That's one of the two things that happened. If the robot's on the field and the light is solid, it means it may have rebooted and lost communication. So it no longer has communication, no longer has an enable command. So if your robot sat there and rebooted for some reason, and you see the light on, you know your robot's on. And if it starts blinking all of a sudden, it means it fully booted back up. One of the things that can cause that is when our radio reboots. If our radio reboots in the middle of a match, your RSL will stop blinking and go solid because it's no longer communicating. Yeah. And then once the radio boots back up fully, it starts blinking again. Now I know I can drive again. If the light is having a stroke and it's blinking really, really fast or erratically, that means you're browning out. So if you ever see a robot that looks like it's stuttering on the field, Is it a mechanical issue or is it an electrical issue? If you look at the RSL light, it will tell you what the problem is. You look at the light, and if the RSL light is blinking nice and solid, no problems, it's a mechanical issue. If the light is jittering and having a stroke, if it's turned into a strobe and we're starting to start raving, then you have battery power issues. That's what's causing your problem. So it tells you a lot more. A lot of people don't realize that. It tells you a lot more than whether a robot's enabled or disabled. It tells you 4 different states. Okay? So always look for that. As the pit crew, they should always be looking. Whenever there's a problem with the robot, they should look at that light to tell them, is this a mechanical issue I need to fix or an electrical issue I need to fix? All right? We also have our servos plugged into our PWM and other PWM devices, digital switches, so on and so forth. Wiring the radio. If we're using the old voltage regulator for our radio, again, plug into the 12 volt 2 amp using the proper size wire. And you're going to plug into a PoE injector and the barrel port. They suggested using both. A lot of teams will still use both because they don't trust it. I will tell you, we don't. We only use the Ethernet port, but we do hot glue it in place, so it can't come out. CAN bus, again, CAN bus carries our digital talking to all those different parts that are CAN bus parts. It comes in a 2 pair, so it's a green, or 1 pair of wires. It's a green and a yellow wire. Again, it doesn't have to be green or yellow, but if you buy a device that is a CAN device, it's going to have green and yellow wire twisted. It has to be twisted. You cannot use straight wires. Do you guys know why wires get twisted like this? Specifically when it comes to data communication. When you run 2 wires over a long distance, those wires will create an impedance and create an electrical field. When you are running electrons down the wires, it'll actually create an electrical field. And electrical fields generate voltage spikes. Data is transmitted using voltage spikes. So if you have 2 wires running a long distance with impedance in there, it's going to actually create false signals in our data lines. And our items will stop talking. When you twist the wires together like this, and you'll always see CAN bus devices always come with twisted CAN wires, it actually cancels out the actual jitteration of that magnetic field. So it doesn't happen. So you need to twist. So if you make your own CAN wires, which we have done tons of times, we will do it we're poor robotics way and put it in one end in a screwdriver and have a student hold the other 2 ends of a long cable and just spin the drill and it'll automatically twist. You got to be careful though not to over twist because you'll break the cables. And then you'll be like, I just made this cable, why doesn't it work? Somewhere in the cable, you just can't see it, you've broken the wires inside of it. So don't over twist it.
So with the CAN bus, does each motor controller have like an identifier? Is that how this is?
When we get into the programming section, we'll dive into it deeper, but yes, every motor controller, every device that talks on the CAN bus has a device type and a CAN ID. Now, this is the part that gets really confusing for a lot of people. The ID, I thought incorrectly when I first started using CAN. I thought you had to like start at 0 and work all the way to the number of devices you have. It doesn't actually work that way. It's a combination of the device type and its ID. So technically, this is a rev controller and this is a Talon, right? They can both have the ID of 1 because they're different devices, right? Or keep it simple, 0, 1, 2, 3, 4, 5, and always put a piece of tape on it and the number it is. Always. That way you don't have to plug in and say, all right, what are you? Put a piece of tape on it and know what exactly it is. But yes, you actually will connect to the device. The Rev Robotics has a USB-C port, and you use their client software. You plug in and you set the parameters, and it saves it onto the device itself. The Talons will communicate using the CTRE Phoenix tuner. Use the Phoenix tuner to set all of the values on their devices. Yep, but you have to go in and actually configure them for what you need. If we ever broke a motor controller during a competition, literally Rachel had pre-made devices that had all the connectors ready to go, and all she would have to do is plug in a USB, set it to the same ID as the old one, and just plug it in, and it's ready to go. So we can quickly swap out controllers without having to change anything other than the ID that it's going to run on. We didn't have to go into code and change our code to use a different motor controller or anything. Pretty cool. Very, very useful. Pneumatics controller, we talked about that. Pneumatics hub is going to connect here. We're going to connect our solenoids, which controls our cylinders, our pistons, into the different port. And in our code, we're going to specify where that solenoid, what port that solenoid is actually plugged into. Here is a double acting, and here's a single act solenoid. So single act is going to push this way for air to go out one hole and come back the other way for air to go out another hole. A double acting is different. A double acting gives you the ability to stop halfway in between, because I can have the ability of pressurizing both sides. So the rod is right in the middle. So I effectively, with a lot of driver practice, you can actually make it stop to at a certain point with pneumatics. Now, I'll let our primary driver, we actually attempted to do this with our claw last year. I will tell you, we didn't end up doing it. Do you want to talk about why we didn't do it? Yeah. And it was hard to get it to stop in the perfect position. It is not a perfect system. You cannot guarantee that I'm going to stop with 3-inch opening. That's not a possibility with it. You can't do that, because it'll also vary on how much pressure is available at that time and what the system load is and what the delay response between the two signals are. So it's just, it is possible. It is possible, but it's almost impossible to achieve effectively. Motor controllers are on their communication bus, not their power lines. I need to specify that more in detail here. The communication bus, the CAN bus, they are normally chained together. How we wire our robots is we take 2 of the CAN wires. So if you have 2 drive motors, I will connect the 2 drive motors together on the CAN bus, and then take the other 2 wires, because we have 2 wires, because you always have an in and an out, right? Now, basically the in and out, it doesn't matter which one. There is no, it's not this one's in, this one's out. They're the just same wire. They're physically connected together here in the hub, but it's meant to be chained from one device to another. We will take one of these wires and connect it to the other co-motor wire. So the other drive controller for the other drive motor. And then we take one wire from both of those and home run it to the star bus. Now we have 2 points of failure instead of 1. If one of the controller's main wire disconnected, it could still see the CAN bus being connected to the other drive motor. If this one had that same issue, or if the one that connected them together disconnected, they still had their home runs to the main bus. You would chain them. So you would chain. So you would come from one device, go into here. This would go to the next device, and then this would go to the next device, and so on and so forth. Yes.
So when you do it the star way, you can't put them all connected. It's only like one in a partner. Because if one connected to the right, you have those two pairs.
Yes, I would take one and go to the star end,
The other one goes to another motor controller, right?
or nothing at all.
But you can't chain them all together and have them all go.
You could actually, technically. You could do it that way if you want. Now, I'm sure we're getting into some aspects of if you have two wires at two different distances and they're both receiving the same signal, this is going to get confused. And the reason it's going to get confused is the signal's getting to the motors at different rates. So that would be the problem with doing a chain and a star all together. You could run into that issue. So again, we've talked about our sensors and we talked about the analog and digital sensors. Here are analog sensors. They can read a range of 0 to 5 volts. So anywhere from 0 to 5 volts. And we have both proximity, ultrasonic sensors, measure distance. We also have potentiometers. Potentiometers are really great for measuring the turn of something. We even actually are using string potentiometers. You can see if something's gone up to a certain point or where it is. There's one game we actually used a very expensive string potentiometer, the Power Up game with the cubes. We actually used a string potentiometer that actually measured the lift, how high the lift was. So we could automate the lift moving up to its position where it should be. So again, using a sensor to detect how long a motor should be running. And once it reaches the point where the physical device reaches the point we want it to be, to tell the motor to stop running. So we used a string. And we could use a limit switch, but a limit switch, what it's going to do is 0 or you're there. A string potentiometer can let us use it at multiple different levels. So we are able to program the robot to say, hey, place a cube on it when it's down at this level. Place a cube on it when it's all the way up at this level, and so on and so forth. We can adjust programmatically the height of our lift. A digital, on the other hand, is a yes or no. A limit switch, hey, we've reached our limit, and we also have digital limit switches. A photoelectric sensor is the same as a limit switch with no physical contact. So it shoots out a little beam, and when something gets in front of that beam, it actually detects, same thing as your garage door opener. Have you guys ever went to shut your garage door and you walked through it while it was shutting? What happened? It should, hopefully. There's some old garage doors that don't. They still decapitate children. But normally you walk through the garage door, it says, oh crap, there's someone here, and it moves it back up. That is a photoelectric sensor. It's detecting something passing through it, right? That is a digital switch still. Even though it has much more fancy electronics in it, it's still giving you a yes or no. It has something in it. This robot that we have up here, that was the yellow ball shooter, has, when we're done with this, if you just walk up the stairs, it has these 5 little photovoltaic electric sensors in it. And the reason it has that is during that particular game, we could hold 5 balls at once. So it would actually detect how many balls we had in the system and automatically run the intake to intake until it was ready to shoot. So again, automating that system. Now, those sensors have to be perfectly placed because if the balls were off or started like bunching up, which was an issue we had with that robot, started bunching up, it would think that there was only 4 because it didn't get up to where it's supposed to be, and it would do this shifty thing. We were telling the robot was being shifty because it would ear with the balls back and forth because it was trying to automatically do it. And in the end, it was a great idea. We did not execute it very well, and we ended up just using the human second driver to control the feed of those balls. Talked about that. The last part is pneumatics. So we have the compressor, the controller, our tanks, the regulator, the pressure switch, solenoids, and our pistons. These are all the individual parts of a pneumatic system. The controller will actually give us the ability to control all of those parts. You cannot have a pneumatic system without a pneumatics controller, period. Your 2 options are the CTRE and the pneumatics hub from Rev Robotics. The Rev Robotics one will control 16 devices, not 15. I put 15 in here. It controls 16 devices. It will power the compressor. It will use a either digital switch or an analog pressure switch, and it communicates via the bus. So the benefits, other than having double the amount of solenoids I can control with it, the benefit of using the Rev Robotics pneumatic hub is the fact that I can actually have an analog sensor and sense how much actual pressure is in the tank. In fact, this actually became really useful last year because one particular game, our claw stopped working. And we couldn't manipulate it anymore. And our driver immediately looked at the smart dashboard and saw that our PSI in our tank was 0. So our pneumatic system had failed. Turns out what happened is one of the supply hoses came unplugged during the game. And it just emptied out the entire thing. So we could see that the compressor was running, but we had 0 pressure. And because we used the smart dashboard, and we knew the compressor is running, but we have 0 pressure, and it's not building up, means something came unplugged, we had the ability to say, turn the compressor off. Stop wasting the energy, a hose broke. We need to just turn off, stop wasting my power. Yep, and Rachel, our primary driver, did that all by herself. Did not need any direction. I trained her well. These are the tanks and the compressors. You can actually use, and I learned last year actually, you don't have to use clipper tanks. Those are what you most often see everyone using. You can actually use any industry COTS part. So any part that is off the shelf, rated for that kind of use, you can actually use. You can actually put a massive tank on your robot if you want to. The compressor, however, you can only use approved compressors, right? And it has to be one of the FRCs. And if you're using pneumatics, you must have the compressor on the robot. So in previous years where teams were not using much pneumatics, they would pre-charge the tanks in the pit and go onto the field with charged tanks without having a compressor. So they didn't have to worry about power use of a compressor. They changed the rules that you cannot pre-pressurize your tanks. It is not allowed anymore. And the main reason is too many teams have the ability to overcharge their tanks, and it's too hard to manage and monitor. If you're using a pneumatics controller and all of those other things, you can't. FMS, all of those prevent you. The controller prevents you from overcharging your tanks. So you have to use a compressor, and you have to use an approved compressor to charge your tanks. You cannot use something off robot to charge your tanks. So it's possible that when you're in line ready to get onto the field, you can enable your robot and charge up the tanks. But you have to do it with the compressor that's on the robot. You don't have to run the compressor the entire match. Right, but you have to use the compressor on the robot. Yes. So, yeah, so I set a very low threshold minimum pressure before it would kick on the compressor on our robot last year. So I set it all the way down to 80, I believe. I think it was 80 that I said it's turn on the compressor value. So sometimes if our pneumatics, we always had micro leaks somewhere. It's just from the robots are hitting each other constantly. You'll develop little micro leaks. We would lose a very small amount of pressure or so, or we just had a match and we're getting back on and the pressure was low. So when we enable a robot, it wouldn't charge them up because it hadn't hit that threshold. So we would actually sit there and let some air out to get it below that 80, so it would kick on and charge it all the way up to the 120. If you have a digital one, that's not really a thing because it kicks on at 110, like something, a value very, very high. The regulator, there are two things that you have to understand about pneumatics. There is stored pressure and there is working pressure. You have to have a regulator that will take the max stored pressure you can have in FRC is 120 psi. The max working pressure you are allowed to use is 60 psi. You cannot have anything over 60. A regulator will actually take that stored pressure and bring it down to a working pressure for your devices to use. Working pressure, so stored pressure is the things that are connected to your stored pressure is your pressure sensor, digital switch, your compressor, and the regulator. That's what's connected, the gauge to tell you how much is in there, right? That's what's connected to your stored pressure. After your regulator, now you have your solenoids, cylinders, and all of those other things. And I would recommend also a gauge. So you have to gauge so you can see what the pressure is other than the regulator itself. Regulator actually has a gauge you can screw into it directly, so you can actually see the working pressure right on the regulator. These are solenoids, and you see here a single acting solenoid and a double acting solenoid. In a single acting solenoid, I can either put pressure out here or pressure out here. So I can push the cylinder this way or push the cylinder this way. You can actually, and are allowed to, power multiple cylinders on one solenoid. So if you have an intake that goes out, you can actually put a Y adapter and plug both of these cylinders into one solenoid. So you have two pushing out, two pulling in. But you cannot have multiple solenoids connected to the same controller port on your pneumatics controller. One solenoid per port on the pneumatics controller. You cannot have multiples. So if you run out of ports, you can't connect two to the same port. So remember that. Double has two outputs, just like a single, but does give you the ability to stop somewhere in between, because it has the ability to pressurize both sides. Cylinders. Cylinders are actually what we use to actually do those actuations. We have a single acting cylinder and a double acting cylinder. In a single acting cylinder, we have one port on either this side or this side, and on the other side is a spring. This is really great for certain actions where I want to just push out and I don't want to use any air to pull it back in again. But there is a cost to doing so, because on this particular cylinder, when I'm using air, this one has the port on this side, meaning it uses air to pull the rod in, and uses a spring to push it back out again. But because you always have a spring in here, you have to use more air to actuate it down, because now it's not fighting now it has resistance in pushing that, right? So it's a very fine line of which one do I use. If I can only run one air hose to this device because it's in a very weird place, spring returns are great. If I need my air to last as long as possible, I'm going to run 2 tubes and use double, meaning I'm going to use air to push it one way, and I'm going to use air to push it the other way. Those are the 2 different types. Now, the one thing I did not write in this that you need to understand, how much power a cylinder has depends on 2 factors, or 3 factors total. Your working pressure that you can work with, which is limited to 60 psi for FRC. That's it. You can always go less, but you cannot go more. You can only use 60 psi. That's a limiting factor. The next 2 factors you have available to you is the size of the cylinder and the size of the rod. If I want to, I could put a big 12-inch cylinder on my robot, and that thing would be able to lift a semi. The problem is I'm powering this entire thing with a little bitty compressor. I might get one actuation out of this thing, and then I'm out of air because my stored pressure is not holding much. So you have to balance power with power. So you have to pick the right size cylinder to use for the right application. And you want to make the cylinder as small as possible, because the smaller the cylinder is, the less air I need to actuate it under load. But the smaller the cylinder is, the less power I have to perform that actuation. So think of it as surface. If 60 psi is pushing on this small little circle, that's what I have. If I have a bigger circle to push on, I have all of this surface area to push on with 60 psi. Was that going to be a lot more power? Yeah. It would be a lot more power with more surface area to actually push on, right? But this is going to use up a lot of power, a lot of stored pressure. We actually had in deep space, we had 2 large cylinders that lifted the robot off the ground so it could climb onto the in-game platforms, that climbed up onto the platforms. Now, I would say, again, we didn't execute it great because one particular time we hit it a little hard and bent the rods on the actual pistons, so we couldn't retract them at that point. But you have enough pressure in an FRC robot to completely pick the robot off the ground strictly via pressure. You just have to size your cylinders to the right size. And we have a lot of cylinders, but it feels like every season we never have the kind of cylinder we need. And we always end up having to buy one.
Which makes sense because they should be applied mathematically to the right situation.
Yes. And I will tell you, we don't always get that math right. We end up buying 4 or 5 cylinders until we find the actual right one. Math is hard. And that brings us to the end of the session today. Do you guys have any questions? I know you're hurting, right? I promise when you get into the season, and you have this, I'm gonna put this recording up in the cloud for you guys, but when you have this, when you go into your season, you'll know, okay, I know what this is for, and that's half the battle.